morning, everyone. And let's wait for a few more guys to be seated. Hi, good morning. Welcome, everyone. Welcome, Lee Siong, our chairman, and everyone here and online. I'm Zheying, or most of you guys know me as Zawa. I'll be moderating today's webinar. We hope everyone is aware that this is a hybrid webinar. So we'll do a quick housekeeping. For those physical here, do make sure that you turn off your mobile phone to silent mode. And for those who are joining online via Zoom, remember to jot down the sign in and sign out code later when it appears on the screen. We are also broadcasting this seminar live on our PAM Northern Chapter Facebook page. Do feel free to share with your friends, but for those who view via Facebook page, they will not be getting any CPD points. Okay. Today we are very happy that architect Chong Lee Siong is back in Penang again after 3 years, more than 3 years, I think. Right. So the topic today is the principles of designing for fire safety with the revisions in the UBBL 2021. I suppose architect Chong is no stranger to everyone here, but in case there are some newbies, architect Chong graduated from Deakin University. He was a council member of Pertubuhan Architect Malaysia, served in the Practice Projects Committee, the Disciplinary Committee, the Building Standards and Legislation Committee, and CPD Committee. He also served as Honorary Secretary in 2006 to 2007, and also Vice President in 2007 to 2008. He's very active in the study of fire safety, engineering from architectural perspective. He's also a member of the Institute of Fire Engineers and contributed to the drafting of the UBBL 2012 and the recent one, the 2021, and also the publication of the Guide to Fire Protection in Malaysia. He also delivered numerous papers on application and interpretation of fire safety provisions in architectural designs. He also shared his expertise as guest lecturer and also external examiner to architecture faculties of UM, USM, UPM, IIUM, Taylor's University, and TAR College. He established Lee Siong Architect in 1994 and now incorporated as LSA Architects Sendirian Berhad. His current and past projects include a wide array of projects from apartments to condominiums, small and large industrial complexes and office buildings, and particularly expertise is in the planning and design of clean manufacturing facilities for the food and beverage, electronics, aeronautical, and automotive industries. Next, I'll pass to our PAM Northern Chapter Chairman, Architect Liao Kuan Chung, to deliver the opening remarks. Chairman, please.
Hi, good morning. Thank you very much for coming. And I see most of you have masks on. I don't have. So thank you, Garis Pixel, for hosting, and obviously our secretariat, who are, as I always say, is very, very efficient. And thank you, Kokchun, that he's here for organizing. I'm not quite sure whether he's here or not. Actually, I have trust in science now. That's why I think I wear a mask, because I already have, I think, 5 jabs already. So don't worry. I think it should be okay. As I said, thank you very much for coming on a Saturday, and also, brave enough to come physically. I think I hope it's because you want to attend, not for all the points. Points helps, I think. Okay, as we all know, understanding the basic principle of design is the key to an efficient and well-designed building. As architects, we know that. Understanding the principle of fire design principles are equally important to ensure that we have buildings that are safe for its occupants and its surrounding. Due to some unfortunate fire tragedy in recent years, Granville and I think Kwan Amina Hospital, Sultan Amina Hospital in Bomba has initiated the process of updating the fire safety prescription, resulting in the incorporation of the relevant bylaws in now what is UBBL 2021. Architect Lee Siong will be revisiting some of the basic principles of design for fire safety expanding the details in the updated UBBL 2021. Something I want to say, but I think I've forgotten. But never mind. Okay, I will not take up any of the time, and let architect carry on with the lecture. Thank you very much.
Thank you so much.
I got it down here actually. I think I'm constantly reminding architects to there will be a training course. I'm not quite sure when. They were talking about November last year. So it's just really a reminder that we encourage all the architects to attend, because Bomba will take it that when you submit, they will want a certificate of attendance from the applicant. And those with the certificate of attendance will get priorities, in terms of actually processing your plan. I mean, I don't know how they actually do it, but they may ask and say, have you attended the course? We started. I'm not sure. Could be this year. I'm not sure.
Yeah, we all.
Okay, so just a reminder only. Thank you very much. Thank you.
Okay, thank you so much. Just a test. Is my mic working? Okay, everyone. Online. The guys online, you're okay with the with my microphone? Okay, great. Thank you so much. I'm really glad to be in Penang again, and I'm very appreciative of this opportunity to be able to come here in person to share with you the latest development on the UBBL 2021. Just yesterday, I got a call from Lembaga Architect Malaysia. They couldn't renew my registration this year because I'm short of 2 points. So they gave me until 31st of January to get my extra 2 points, and said, okay, I'm coming to Penang today. So after this, I should be getting my 2 points just enough. That's the problem with the MCO, because we just sort of stay at home, don't do anything. All these seminars and all that I do is all online now, so we don't bother registering. We have no proof of attendance and all that. So yeah, so Bomba finally, Lembaga finally caught up with me. Okay, I'm really glad to be here today. This new UBBL 2021, it's almost like an exact repeat situation of what happened 10 years ago. 10 years ago in November, exactly 10 years ago, in November 2012, we gazetted, or rather, the then Parliament gazetted the UBBL 2012. And at that time, of course, Bomba and all of us in the industry, really all the amendments in the UBBL, of course, it consists of things like the CCC, all the warranties, all the submission procedures and all that. But 2/3 of it is really made up of fire safety provisions in Part 7 and Part 8. So Bomba was the driving force in getting the UBBL updated. So in 2012, December, it was gazetted in Parliament. Selangor was the first state to immediately gazette it for implementation in the state of Selangor. Then that was it. Nothing happened until a long time later. And Penang only just gazetted 2012 just about 2 years ago. So now we got 2021. So the main issue that Bomba has been facing is that they couldn't quite get these fire requirements. They couldn't quite find the correct platform for them to impose it, or for them to get it adopted nationwide, because fundamentally the Uniform Building Bylaw is a federal gazette. It has to be gazetted or adopted by the individual states, because this is a home matter. It's a local government issue. So this round, Bomba is trying their luck again, doing exactly the same thing. So they wanted to use the Fire Services Act to say, okay, I'll issue the directive now that anything related to Bomba, anything related to that, you shall use this. I think they are quite adamant that they want to do it that way, but up until today, I think they still couldn't haven't quite figured out how it's to be done. The initial intentions is to direct all the various states on the bomba and all the different states to actually enforce it in that manner. So they've set the date from January 2023, which is about 4 weeks away to adopt this. And we also understand that whenever you implement laws, the Uniform Building Bylaw is actually a law, right? So in Bomba, can't get a law to be developed in local states. Bomba cannot introduce a law. All Bomba can do is introduce a directive that says you shall follow that document, and that document until it's gazetted by the state, that document is not a law per se. So Bomba has that issue. But again, as with any other laws, when you introduce it and you have a particular cutoff date, you have to have a law of implementation as to when it can be adopted, what is the grace period, and what will you do with, say, projects that were approved but not built prior to that date, etc., etc. So there are a lot of these things, and Bomba hasn't quite got the legal expertise to be able to work through all these necessary how should I call it, all these necessary terms as to how a law can be implemented. Okay, we are assisting them. If they ask us a question, we'll answer them. We are assisting them in any way we can, but ultimately it's still up to them. I think the best way, the most likely way they will get it introduced or they get it enforced is by the directive, via the Fire Services Act. They just have to get the act together and ensure that every single fire department at the state level recognizes it and adopts it. So when you submit it in building plans, you may get it approved in your local council. But when you go to Bomba will say, no, you have to have that first. Yeah, so I think that will probably be the way it will be implemented. So let's see what happens in January 2023, in 3 weeks. Having said that, if you are already doing plans, if you're already doing designs now, to be submitted in the next few months, I'll suggest, yeah, please do adopt this. Do adopt this UBBL 221. Yeah, because from a fire safety point of view, this is the way to go. That's the way to go forward. Okay, I'll just get down to it. All right, what I've got over here is that you'll see a lot of familiar slides because these are the same thing that I've been using for the last 10 years, more than 10 years already. Oh, sorry, my apologies. I have to share this one. Okay. This is a very strange arrangement. No, I think it's it's been a few minutes. I think this angle back here. It is supposed to. Okay, is this better? Can everyone hear me now? A bit soft, huh? Echoey. Oh, because there's this laptop is got the speaker on. I can't turn off the speaker on this laptop. See, there's still speaker. Okay, is it better now? Okay, online, is it okay? There is a bit of echo from the speaker here. Yeah, it can't be Oh, okay. All right, I'll just stand a little bit further. Okay, good, huh? Okay, great. Okay, my apology. Right, okay, so the Uniform Building Bylaw, okay, just to recap, what I'll do is that I'll go through the slides as it is, and whenever we arrive at the areas that have been changed or the areas that have been updated for 2021, that's where I'll do the elaboration. So I'll go pretty fast because a lot of the other items are already what we have been doing over the last 15 or 20 years. So I'll go pretty fast through that. Okay, so just to recap, the Uniform Building Bylaws are actually a prescriptive building code. It is a law, right? Unlike a lot of other standards that we may be familiar with that we use and all that, those are standards. Whereas this document that we are using, actually we're not supposed to be using the Uniform Building Bylaw as our guide to designing building as our standard, because this is actually a law. It's the same way that you don't learn how to drive by studying the traffic laws. You don't learn how to drive by doing that. You learn how to drive by physically learning how to drive. Then you learn the laws to give you the limitations or the descriptions as to how you should behave on the road. So the law is just that. It is a prescriptive building code. It doesn't tell you how to do things. And it doesn't tell you why you should be doing it. All it says is that you shall do this, you shall not do that. Whatever you design cannot be smaller than this, cannot be bigger than that, cannot be shorter, cannot be longer, etc., etc. Right. So following on to that, we have the Malaysian standards, of course, and Malaysian standards not only 1183, but 1183 is the overall standard, I shall say, that prescribes fire safety. So standard is more descriptive. It provides informative descriptions. It establishes what is common and good practices, and most importantly, actually describe the performance criteria expected of a design. For any particular element, it will actually describe to you what is expected. Why is it that that issue or that particular element, it should be considered in a particular manner, and what would be the right way to do it. So the UBBL sets the parameters, the law, where you cannot exceed that threshold. If you exceed that, you're breaking the law physically. Whereas the Malaysian standards, by understanding it, you'll find that, yeah, now we understand why are the laws given has got those limitations. And of course, all laws and everything, all documents develop over time. They can never be perfect. So 2021, UBBL 2021, for all intents and purposes, is the development of 2012. And 2012 itself is a development from 1984, the very, very first bylaw we have had. So I couldn't believe it, Malaysia. We only got our first uniform building bylaws in 1984. Yeah, so I came back from Australia, started practicing here in 1991. So technically, the bylaw was only in place for about 6 years when I came back. Whereas when I was practicing overseas, we were looking at bylaws we were looking at these laws that were written in 1932, 1940, 1950, and they've been developing over time. So Malaysia is a very, very young country. But of course, we have come a very, very long way. And I have to say, the UBBL 2021 that we got today is really, really right up there. At least in terms of its intent and content. The law itself may not be written to the same degree of legal finesse as we may expect. In some ways, it's a little bit down-tuned to be more deliberately down-tuned a little bit, so that it's more practical for application, practical for understanding, but the content behind it is actually very, very high. It's reviewed from the Malaysian standards, and also if you look at the notes that we were using and the references that we were using in the development of the UBBL 2021, you'll find that we have actually referred to a lot of international standards. I'll share with you as we go along. Right, so coming back to the concept of basic concept of fire safety. Okay, first concept of course, evacuation. No matter what you do, you design for evacuation first, followed by passive containment, then active intervention, and last but not least will be access for firefighting and rescue. So to recap again, items, specifications or prescriptions related to evacuation, passive containment, and active intervention. These are specific prescriptions with reference to the purpose group of the building. And also within each purpose group is very specific occupancy, the height and size and height of the building, and all the references of that from the purpose group. Then it goes through all the other references of schedules 5, 6, 7, 8, 9, and 10. This is for evacuation, passive containment, and active intervention. Whereas any provision for the purposes of access for firefighting and rescue, it's common to all building types. Right? And this one is prescriptions with reference to the height and volume of the building for all building types. Now, it doesn't matter whether it's a residential, other than single residential, everything other than single residential. Any reference to height and building volume and all that, the same applications apply for access for firefighting and rescue. Right? Whereas for items related to evacuation, passive containment, active intervention, there'll be very specific prescriptions for the purpose group, occupancy, type and size of the building. And for UBBL 2021, we did some additional clarifications in the purpose group. Actually, it's much the same as 2012. And Penang, you already adopted 2012, so you will be quite familiar with this. We've only added a little bit more with regards to prescriptions on the place of assembly, and particularly on the and particularly for the place of storage in general. Here we've particularly included vehicles, that means car parking. Yeah? Previously, it was just assumed that car park did not appear in any category. We just say so it goes to storage or general, any other thing. But now it's specifically included. Right? It's particularly recognized that the car parking is categorized as purpose group. Sorry, my okay, got it. I'm amazed at all this modern technology, remote control cameras and all that. Okay, so on the purpose groups, now how do we categorize purpose groups? Purpose groups are like we mentioned just now: evacuation, passive containment, and evacuation and active intervention. Those items are specifically tailored to meet the specific purpose groups. Now, active intervention, passive containment are also entirely to lead to one purpose, and that is to facilitate evacuation. So the more complex the building, the more means of protection or the more mitigative measures you have to dial in for the purposes of effective evacuation. So it all comes back to the occupant characteristics. The entire life safety code here is all about life safety. It's not so much about the protection of the building. So we start with the occupancy characteristics. And there will be two general broad criteria or broad parameters we'll be looking at. First one is, are the occupants familiar with the building, or are the occupants not familiar with the building? In the primary occupancy of the building, are the occupants awake or are the occupants asleep? Right, so it will be the first, the familiarity, and then secondly, what is the state of mind or the physical the state of the physical mobility in the building. So from here, you can see that officers You'll be very, very familiar. I believe all of us, when we are working in an office, we are all wide awake. You know, you're not sleeping when you're working in the office. And you should be familiar with the office, right? I assume you go to work every day. So you'll be thoroughly familiar with the building. So you're very, very familiar and you're wide awake. So officers will occupy that corner, right? At the other extreme end, if you're an inpatient in the ICU in a hospital, you'll be very much, how shall I say, sedated. You'll be on the bed, you're probably immobile, let alone being familiar with the building. You don't even know where you are. You're in the ICU. So that would be in the very, very extreme end of this corner. And with this one, we'll be able to then categorize the degree of severity in terms of the occupant, the risk to the occupant, right? Of course, if you're immobile, you're in the ICU, you are sedated, you won't be able to help yourself to evacuate. Whereas if you're in the office, presumably you're not sleeping on the job, you should be able to jump out the window very, very quickly. So from there, you will find that with this category, we immediately will be able to then correspond allocations of travel distances with the exit capacities to these categories. You'll notice that buildings or purpose groups that are generally in the safe area, in the green zone, you allow greater travel distances because people, you can run, so you can cover a greater distance safely, that is, and exit capacities are generally allowed to be wider. Now, this one is converting. What we're saying that the capacity is bigger. So the bigger number means for a given unit width of exit, you can accommodate more people. That means you can have narrower exits for the same number of people. Right? So you have to work it that way. So in an office, yeah, for so many occupants, you'll find that okay, that width, that narrow width is sufficient because everyone is awake. You'll be pushing and shoving everyone here and everyone will be able to get through the door. Whereas on the other extreme end, in a hospital, inpatient, ICU, not only is the patient not able to move, but he's probably strapped to a stretcher, the evacuation stretcher, and you need two other people to be pushing the patient out. So you won't be able to travel a very great distance. And the exit capacity is very small. So for any given width, you're only allowed to measure it for the exit of a very low number of people, which means that consequently, you would need a much, much wider exit way to cater for the same number of occupants, right? So for that reason. And the good thing about the bylaws is that you don't have to figure all this out yourself now. All you have to do is just look at the correct schedule and point to it. Right? So that's a good thing about bylaws. While it is not too informative about how we arrive at all these figures, it does give you the general guideline. Once you comply with it, you're deemed to comply and your building is deemed to be safe. Right? That's the whole purpose of the bylaw. Right, so okay, let's go on to evacuation. Evacuation, we're all very familiar with it now. The evacuation involves detections, alarms, exits, travel distances, components, and capacity of exit. These are all the things that that are defined that are described in the UBBL. Right, the accepted assumption in designing for safe evacuation, always remember this. The law does not expect you to design for all situations. That would be for us as an architect. When we are designing a building, it is for us to figure out what is the best for the particular purpose of the building that we're designing for. Right, that is our job. That is our obligation and our professional responsibility, and hence the liability that comes with it when we are doing any project. Right? But what the law does is that the law is just giving you a very broad frame. And say if you make this assumption, you would have exercised the minimum degree of professional discretion. That is all it says. right? So only one fire at one location at one time. All the law only says that is sufficient. I think there are a lot of people raising their hands. Huh? Is that yeah, online, a lot of people are raising their hands. Are they? Can I hear something or? Their chat. How do I turn on the chat here? Oh, now I got some thumbs up. That was earlier. Is it? Okay, now I got thumbs up. I got one waving. I got one thumbs up, two thumbs up. I got a couple of I got one heart here. Okay. 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 I'll go. If there's a problem with the sound, maybe just put it on the chat group. Then I'll get the administrator to voice it out. Okay. So on the evacuation, so as I'm saying, the law just gives this very minimum criteria. As long as you define with the assumption that the fire will occur at only one location at one time, you have done your minimum, you have complied with your minimum expectation of your professional service. Yeah. Of course, if you're designing the new American embassy, you know that the American embassy will have a very high risk of not only having one fire at one location at one time, but it's got multiple bombings from air, from ground, from whatever. That is your architectural prerogative as to how you design the building for specifically for your client. Now, when you recognize a specific risk, you have to design for it. Yeah. Okay. So with that, okay, I'll just share you. I'm sure most of you have seen this script before. Okay, just very short. This one just puts us in the frame of mind as to what exactly are we doing when we're talking about designing for evacuation. Okay, this scene is that there's a kid over here staring at his new electric bike. His electric bike is connected to a charger. So the electric bike is being charged in this one-room apartment. And that is an adult beside him on a lazy chair, just minding his own business, maybe dozing off. All right, now this is in real time. Now, now I don't even know how to start the video now. Oh dear. But press on that. No, I don't. Turn on my laser pointer. Hey. Okay, it's moving. Okay. Okay, that's a spark. Okay, that's it. No? So it's only less than 5 seconds. So the kid is looking at his electric bike. He's wide awake, obviously. The adult is half dozing off, but they heard the sound, the pump, and they saw the smoke. So the adult went out there immediately, checked on the bike, and the smoke increased, and he grabbed the kid and they ran out, and the whole apartment exploded. So this is a very compact scenario. You're talking about a few seconds, yeah. But that's exactly how fire happens, and that's exactly how you need to get people out. First, that's the detection. When a fire is to occur, there has to be a mode or a means to detect it. In this small situation, in this apartment, who is the person or what is the mode of detection? It is the people themselves. The kid probably couldn't do much. The kid saw it and he was wondering what's going on, but it was the adult who heard the explosion. He woke up, he went to investigate, and it was an adult who decided that I think we better run. Yeah, that he can't, don't try to put out the fire, don't try to save the bike. Okay, so it relied on that. First, there's a detection, then someone has to raise the alarm. And then someone have to say that you better evacuate, and you better evacuate. Okay. So to put it in a chart form, they always say like, in order to fight your enemy, you have to know your enemy. Sun Tzu's Art of War. So in this case, we have to understand the characteristics of fire, how it builds up, for us to be able to design adequately to help to suppress the fire. So fire temperature, size, and the time. Okay, my mouse is playing up again. Okay, so the temperature will start with the first stage. The first stage will always be the ignition. You have oxygen, you have heat. Well, you have the fuel, you have the oxygen, and then you introduce sufficient heat to the point that the fuel can release its carbon molecules for the oxygen to hang on to, then you have combustion, right? So that is the first stage. And if you got sufficient fuel and the heat is sufficient for that combustion process to continue, good, the fire will start to eat its way and it will start to grow and it become hungrier and hungrier exponentially. And you'll hit a point in time where, boom, the temperature reaches the height where, okay, everything else starts to combust. And that situation will be known as the flashover. Yeah, I'm struggling with this mouse. Okay, that situation will be known as the flashover. Right, the flashover is the point. It's a bit like your oven. You set your oven, you want to roast Christmas turkey. You set your oven, what is the temperature to roast a turkey? 200 degrees or 250? Okay, let's assume it's 200, 200 degrees. So you set at 200 degrees. All right, at 200 degrees, when the oven reaches that 200 degrees, everything inside it, you'll find that your turkey is supposed to start browning. Everything inside the oven, you're putting your tomatoes, you don't put lettuce in the oven, right? Okay, the carrots or whatever, they will start to brown because it's 200 degrees. You set it at 300 degrees, boom, everything turns black. So flashover refers to that condition, whereby the temperature reaches that particular threshold where the contents in the building, the contents within the oven, within that room will start to combust, right? Naturally, without the introduction of any flames or anything, because the temperature has just reached that, it will start to combust, right? So that degree is called the flashover. Now, if we are in this room, if you imagine this is the oven, and the temperature is rising gradually due to a fire, at what point do you think we here would be able to withstand before we faint or before we get a suntan or before we roast, right? Is it just before flashover or what? Yeah, it's actually very, very early because we are not meant to be in ovens. We live in, even if we get 40 degrees outside, we're going to faint. We're going to get heat stroke already, okay? And worse, it's not only the heat that kills us, it's the smoke. In a fire situation, there are lots and lots of smoke, and we appreciate very, very fast. Give us 10 seconds, hold your breath, and the average person will start to faint. So the condition is known as untenable condition. And untenable condition occurs very, very, very early on in the stage of the fire. For example, that electric bike explosion incident. The untenable condition was literally just a few seconds before the thing explodes. The moment the thing explodes, the entire unit was engulfed in smoke already, and the untenable condition was reached so suddenly. Now, one moment you got clean air, next moment the entire building is engulfed. So designing for evacuation is for us to look at that very, very early phase of the development of the fire. If I enlarge the graph a bit, so you have the ignition, and the fire starts to grow, and it reaches untenable condition. This is not flashover, but untenable condition. So at this point in time, between the ignition of the fire and when the condition reaches untenable, that is called your available safe egress time. So in the apartment fire just now, the available safe egress time was something like less than 10 seconds between the ignition and boom. So they've got 10 seconds of available safe egress time. The two occupants in that condominium must get out within that time. So when we do the design, of course, when we, in terms of available safe egress time, in terms of getting the people out, you must first be able to detect the fire, right? Then after detection, you must be able to raise the alarm for you to determine that, okay, I can't put out this fire, I have to run out. Then you have to actually start moving. And finally, you need time to get to the door and slam the door behind you when you leave. Then you shut the fire behind you. So that's also evacuation. So in any incident, it goes through this exactly the same thing, right? First, there's the detection, then there's the alarm, and then there's the movement, and then finally total evacuation. So the way we design fire safety and the way we come up with the prescriptions is that we will want to make, okay, this is called the required safe egress time. Now, we will want to get the people out, or we want to be able to design the facility to allow all the occupants to be able to get out of the building within 3/4 of the available safe egress time. That is what we do. Yeah. Now, if you are going for a performance-based approach in your design, this is exactly what we simulate. We have to put in all the parameters of the state of mind of the occupants, the composition of how many adults, how many young people, and who are on wheelchairs, and how many people are able-bodied, etc., etc. Or if you're designing a performance-based for a hospital, even worse. Yeah, you have to start putting in the parameters and all that. Then you have to simulate what will be the fire load, how will be the smoke be developing, what is the smoke evacuation, what is the desired smoke layer for us to determine the available safe egress time. Then we do the simulation to check whether we can get the occupants to get out of the building within the required safe egress time. Right? Of course, the good thing with having the bylaws is that you don't have to go through all that effort now. You just comply with the prescriptions in the bylaw and you're deemed to comply. Yeah? All the numbers that's in the bylaw is actually taken from a lot of studies, both internationally and local, for us to come up with a set of laws and say, okay, it's deemed to comply. It's the same like your speed limits on the highway. Who is to say driving 110 kilometers an hour exactly you're safer than driving 111 kilometers an hour? Because you drive at 111 kilometers an hour, you get a summons. Right? So, okay, and who is to say that in heavy thunderstorm, I'm driving at 110 km an hour, I'm not getting a summons, but are you actually safe? Because you're not supposed to be doing 110 km an hour in the thunderstorm, in the deluge. But that's what the law is. The law gives you a very general guideline and says that if you keep within that threshold, you're deemed to comply. Right? So you don't have to go through the performance-based approach, unless your particular design requires it too. Okay. All right, so we come to exit. All right, now we're speaking about components. We have to recognize these terms. When we're designing for exits, we have to recognize what is known as the final exit, alternative exits, story exit, and horizontal exit. I've got alternative exits in inverted commas because alternative exit is not actually described term, right? You have final exit. Final exit is one definition. Story exit is another definition. Horizontal exit is another definition. And any of these, final exit, story exit, or horizontal exits, can make up alternative exits. Alternative exit is a requirement that on every floor, you must have an alternative exit. That means you cannot rely on just one mode of exit in one direction. You must have alternative exit. And exits can be, of course, the final exit is final exit lah. You're supposed to hit to a final exit, right? But before you hit to the final exit, you can have story exits and horizontal exits. And any of these will have to be configured for every floor to have alternative exits. Okay, yeah. And then connecting the final exit with the story exits and the alternate and the horizontal exit will be what is known as the exit route. Right, the final exit, the interpretation. Okay, I'll just go on the final exit. Final exit refers to the threshold that separates what is still within the building and out of the building. The liability of your design for evacuation, as far as the building is concerned, the architect is concerned, our liability ends at this point. So our job is to design for evacuation. And it is to get people to the final exit. Once you kick the guy out of the final exit, once he crosses the threshold, you're able to throw him out of the window, out of the building, your liability stops. If he runs out of the exit and he gets knocked down by a car, okay, you may be called in to explain yourself. Well, why do you put the final exit discharging straight into the highway, but as far as the design is concerned, but as far as the design of the building is concerned, your design inside the building stops at the final exit. So the point is that evacuation, you must get people to the final exit. The alternative exit is just from UBBL 166, where it just says that primarily concept of fire evacuation, every floor space shall be provided with at least 2 exits on the basis that if one exit is inoperable, the other exit can serve its function. Like, this is the one thing in the Malaysian bylaw that has really saved us, has really saved a lot of lives. We all know about the Grenfell Tower. Okay, we've been talking about the cladding, facade, fire, and all these things. But the Grenfell Tower has got one single core and one single exit in the core. Of course, the moment that became incapacitated, that's it. The entire tower is a death threat. Singapore is also practicing single exits for condominiums, but they've got a lot of other mitigation measures, right? To design for that, they got so many other provisions. So it's not as simple as that. Okay, Malaysia, we are not up to that level of providing so many of the other provisions. But I will say, please keep to this concept. Don't attempt to change it. Don't try to be clever. I'm actually telling a lot of people in the community, please don't do it. That's it. So fundamental, so basic. There's no skin off our back. It doesn't cost us any more to make this provision. Later on, I'll talk about the single fare provision. But this is really the primary concept. Okay, horizontal exit. Horizontal exit is generally an exit that leads to an adjacent separated compartment within the same floor. And the story exit is the exit from a floor which is of a different level from the final exit, etc., etc. And the exit route is generally the protected passage from a story exit that leads to a final exit. And this can include places that are designated areas of refuge, anywhere between the story exit and the final exits. And then the travel distance. Now, this is where the travel distance comes in. Travel distance will have the dead end limits, the direct distance, and the open plan distance. Right? We should be quite familiar with it now. Good. The first thing that is now introduced in the UBBL 2021 in the 7th schedule is this additional column. So we are now recognizing that corridors are actually subjected to travel distance limitation. And in this case, it says dead end. Basically, what it means is that corridors, you're applying the same travel distance where there's a two-way travel and where there's a dead end, right? Especially corridors. But of course, if you look at it carefully, you will find that the corridor dead end is exactly the same prescription as the building dead end. Sorry. Okay. Okay, but okay. But the power is still on, huh? Okay. Okay. So let's go on. So we'll let everyone know there's potentially a power interruption, a power outage for 15 minutes. So I'll continue. The moment I go blank, that's our break time. Okay. And then we'll come back when we go back online. Okay. All right. So we have now recognized this corridor, dead end. And this has always been a point of contention last time. Actually, we have always known exactly how it should be done. But it's just that because the bylaw was silent on this, it just left that gap for a lot of interpretations. And we have to understand, architects don't help bombard too much also, because a lot of times we also try to, whether knowingly or unknowingly, interpret it in different ways. And bombard themselves, they're not too well versed on this also. So that's where a lot of conflicts have occurred. So now we've added in this column, and the purpose of this one is then now for the purpose of the definition. And also, yeah, on the 7th schedule, we have finally added in the parking garages, car parks into the schedule. Like last time, it wasn't in there. So there are a lot of head scratching as to what exactly do you do in that car park in terms of travel distances and in terms of exit capacities. So car park is now in the 7th schedule. Okay, so exit route components, exit doorway, exit discharge, exit protected corridor, balcony approach, single staircase. All right, over here, we talk about exit door and exit discharge, and then we also talk about exit. So exit really just refers to that threshold that you go past, right, and exit. That's referring to the threshold. When we refer to the door, the physical door itself is a prescription as to what door is it that do you have to put a door there anyway in the first place, over the exit. So the term exit and doors are actually separated. They're very, very much interconnected, but you should be looking at them separately. So exit, just when you talk about exit, it doesn't necessarily refer to a single type of a door, right? The door has to be by its function. So on that basis, just remember this few key phrases here. Not all fire-rated doors are exit doors. I think that one is very obvious. And not all exit doors need to be fire doors, right? That's also, it is actually quite obvious also. And not all doors need to be exit doors. You do a door, that doesn't mean that every door will have to open in the direction of travel and get people out. No, not necessarily. Not all doors are for exit purposes. Exit doors are designated doors. That means you design and you designate. That is your exit door. Everything else is your own accommodation, for your own accommodation purposes, okay? And on that same token, not all the doors you design can actually be an exit door. All right, so it's very, very interrelated. Okay, to qualify as an exit door, now I'm referring to the door itself. To qualify an exit door must always be able to be open without undue effort at all times. So it's very simple. An exit discharge must always allow the passage of people at all times. And that is what you designate, right? You can have many, many doors, but they're for accommodation purposes. You need it for security, you need it for crowd control or whatever. But exit doors, you can have all your accommodation doors to also function as the exit doors. You just need to then configure it in a manner that it can have that dual mode. Under normal usage, the doors are secured with card access, for example. But if you designate that door to also function as exit door, in the fire alarm mode or in an emergency, there has to be a means to be able to totally disconnect all the access controls, and the door will then function, push open to function as an exit door. Right? So yeah, just having the understanding would solve a lot of clarification. Even the fire department, sometimes they get it on the spot. Now you do design all the doors and then, oh, ini semua keluar, ini semua mesti letak keluar sign, semua mesti ada keluar sign. What? So it happens, it happens. You've seen a lot of situations, right? If you do a lot of, say, cafe fit outs and all that in, say, apartment complexes, you've got the entire shop front fully open. That's your cafeteria in there. You see out, you see the rest of the mall right in front of you. Among all the flashing neon signs and all these things, Bombastic asks you, please put the keluar sign here. It's like, what are you doing? As if we don't know that that's a keluar. Right? So sometimes it happens, but yeah, as long as we understand what we're actually doing, clarity of signages and all that is actually very important. And exit in this context means the story exit, horizontal exit, or final exit. Ultimately, we still come back to these three definitions: story exit, horizontal exit, and final exits. And then, of course, there are also protected staircase and protected doors. All right. This is a simple diagram to illustrate. This is a cross-section of a single building. So these people with their hands running out, if they just run across and they are out of the building, that threshold is called the final exit. Before the threshold, they're inside. Beyond the other side, they are on the outside of the building. If we stack up this same floor plan into multiple levels, then that final exit, what was originally the final exit now, because it's on the upper level, unless you design that, unless you still keep that the final exit, that means you don't have staircases here. You say that's the final exit, they're out of the building already, jump off the window and they're out of the building, right? But of course, we can't do that. So the equivalent of the final exit, the condition here is exactly the same. They have to meet the same evacuation reset time, the required safe egress time of the same floor as all the other floors, same as the ground floor. So in order for them to meet that, they can't have a final exit here because the final exit is way down here. So this configuration then is that the final exit is now here at the ground level, but they have to reach the same degree of separation or isolation from the fire behind them at the floor itself. So that function is taken by the story exit, right? What would actually have been the final exit is now a story exit because it's not above. And connecting the story exit to the final exit, this will have to be a safe passage, and that will then be known as the exit route. Right? So it's the same thing. When we have, if we have an internal compartment in between the same floor on the same horizontal passage, the person runs from that compartment, crosses that horizontal exit into the second compartment. Now that would then be the horizontal exit before it reaches the story exit, which then brings them vertically down or up depending on the situation by the exit route to the final exit. Yeah? So the travel distance limitations is within any of this fire compartment measured from the most extreme end of that compartment to the story exit, horizontal exit, or a final exit. So those will be the limitations of the travel distances. As to what this horizontal exit actually does, remember we now introduce the recognition of a corridor. So when do you apply the concept of a corridor, or when do you apply the concept of a horizontal exit? Right, let's go back to some very basic diagrams. With a single room like that, there's a final exit. And that measurement is the travel distance. In this case, if you've only provided one exit, provided you can do so under the single stair category or whatever, that is also the dead end because you got no alternative. Right? So that will be measured as travel exit. If I just widen the room a bit, now you've got alternative exits, and then you have the travel distances. So you're not limited by the dead end distance anymore. You can go all the way up to the travel distance to the final exit. Now, if I bring this floor up the stairs, so exactly the same situation. Now the final exit is no longer a final exit, it is now a story exit. So that goes into the protected stairs, which is green, for you to be able to reach wherever your final exit is, the level of final exit. If I widen the, make the floor space much bigger, concept remains exactly the same. It is also whatever the travel limitations are within this space for you to reach the story exit that will eventually lead to the final exit. If I start putting non-fire rated partitions, your rooms, offices, internal partitions, non-fire rated, then your travel distances will be measured on the direct route of travel to a doorway or whatever leading to the story exit. You can't measure it through the partition for all these reasons. You're not supposed to walk through partitions to get to the exit. Now, if you turn these non-fire rated partitions into fire rated compartment walls, for example, separating individual units or say different office suites, different parties, and these are actually fire rated and they're compartmented. Now the method of measurement is now different. So now you'll be measured this way. That compartment will have its travel distance limitations. And these doors will now be the horizontal exits. But of course, it has to be fully fire rated. Right? This is the same concept. Yes, if it's red, means it's fire rated. As opposed to, like in this situation, where it's non-fire rated. Well, yeah, it's the same. Actually, it's the same application. Right? Say in the condominium, if this is one single condominium, these are your internal partitioning: master bedroom, bedroom 2, your hallway. Right? Within here, your travel distances apply all the way from the most extreme corner of your apartment to the story exit. And if this story exit is your front door, that means if you have a single one unit floor arrangement, you come off the lift lobby, and that is your private lobby already. Yeah, so your travel distances inside is measured all the way to that story exit. And because it's an entirely your own apartment, right? But if it's separated, as in most situations are, we're like this: when each one of these is one private compartment, you have a fire-rated door here, and this becomes a protected corridor. Protected means protected, fully ventilated, whatever means of protection, right? But protected means it's fully isolated from the fire compartment. Then this becomes horizontal exit. Which is why a lot of condominiums actually got fire rated one door for this purpose. Those are protected corridors. It's protected by natural ventilation. Yeah. Yeah. Protected here means separated from the fire, from the occupied space. And that corridor is not meant to be habitable. That means you don't set up a surface door, that kind of stuff. Protected doesn't mean fully enclosed. Protected just means protected, right? If it later on, I'll go into the various definitions of protected. So yeah, in this situation, then the travel distance will apply within the compartment. And once you go through the horizontal exit, the travel distance applies for corridors. Right, so you've got two-way travel. It actually is exactly the same. The dead end limit and the travel distance, so sprinkler and sprinkler is exactly the same. It's just a recognition that a horizontal, a protected corridor for all intents and purposes is a horizontal compartment. Actually, this is what we've always been doing, but we just had to put it in the bylaws now so that there's no more ambiguity. Double dead end, correct? Yeah. So if you have a very small apartment here with just a single door, you got the dead end here, and we come over here, the stair is say somewhere here. So you don't have an alternative exit to the other side. So that's the other dead end, the corridor dead end. Okay. Now, this concept is also applied. Oh, sorry, you're still looking at that now. Okay, now this concept is also applied to compartments, large compartments within the building. So horizontal exit, you got one compartment discharging into the secondary compartment, and then it goes to either the story exit or the final exits. Right now, if you have a situation like this where you have three compartments and you got the inner compartment, so you may think that okay, I'll get compartment 1 to discharge into compartment 2. And then compartment 2, I'll get them to discharge on the compartment 3. No, you can't do that, because the whole purpose of the horizontal exit is just gets you through one compartment. Then you have to be on your way to a story exit or final exit. So if you do actually have a situation like this, the correct concept would be this: you have the inner compartment. The inner compartment can only be one layer away from outer compartment. So the one in the middle will be the single inner compartment. And this inner compartment will then have the alternative exits. Because it's alternating, you either go to the burning compartment 2, or you want to go to the safe compartment 2 on the other side. That's why there's alternative. And then from within the compartment itself, it also functions as alternative. So you have the travel distance limitations here and the travel distance limitations in this compartment. Right, that would be the way it works. Right, and then sorry. Okay, in the situation of that concept, you can, but you will want to define it this manner. If I go back to this, right, if you have a very, very large condominium here, say over 2 stories and very, very deep plan, there are travel distance limitations within your own compartment. Dead end, in UBBL 2012, the dead end was 20 meters. So now we have reduced it back down to 15 because of this concept here. So you're allowed to now play a little bit more with the applications of the horizontal exit. Right, so within this one here, you can say go to a horizontal compartment, these 2 ways. But each one of these compartments is still will maintain its own travel distances. But each of these compartments will then have to go through one horizontal compartment before it reaches the story exit. So they must have the alternative. It cannot be a situation where this horizontal exit, this protected corridor is over here, and this compartment will have to discharge into that before it goes into that corridor. The same concept still applies. You can really only get people through one layer of horizontal exits. Same concept will apply. Because the risk is always that if you're the inner compartment, the fire is occurring in the outer compartment, then you have no alternative anymore. And that is always key. Horizontal exit, that's correct. Well, now you have to. Yeah. Because if you have not fire rated it, that means it's actually not compartmented. So you have to take the entire travel distance to the end of the corridor wall. Okay? Yeah. Correct. Actually, it's always been that way, lah. Yeah. Yeah. But it's actually always been effective. That is why. No, it's on your travel. No, it's on your travel distance. It's not that you must have a fire rated door here. Yes, that's correct. Yeah. If for your travel distance, there's absolutely nothing wrong for you if you do this. Yeah. Yes, it is. Yes, it is. You're talking about the door, because when you have a party wall fire rated, whatever openings you put through the door, it must be fire rated to the same degree as that wall, for that wall to function as the compartment wall. Then it renders this entire line non-fire rated. Yeah.
Sorry, because for the benefit of those online ones, if we are asking questions like that and they can't hear very clearly, they have no idea what is happening. Maybe we can wait that you use the mic. No, I think we can do it
Okay.
immediate. It's just that ask questions, just get the mic, or maybe Lisa, you can repeat the question.
Yeah, not a problem.
Yeah,
Okay.
they're all in the dark. Not sure what's happening. Sorry for that.
Okay, the question was asked is that most of our walls anyway are constructed in brickwork. So yeah, they will carry a 2-hour fire rating. Not like in this situation. Well, most of the time we think it's this situation, where the walls are constructed, and yes, it's recognized as a compartment because there is the other law. Every single residential unit must be compartmented and separated from all the common areas. So separated really means just that. And if this separation is that of a wall, and it's not a horizontal distance separation, like say through an air well, we are allowed 2 meters of horizontal separation. So that you can have your windows and doors and all that. But if it's right against that defined corridor or the defined adjacent unit, like a party wall, then of course it must be fire rated. So any openings through that must be fire rated also. If that door is not fire rated, then you've rendered this entire wall non-fire rated. Right? That would be the interpretation. Okay. In terms of the compartmentation, any wall, any protection of the opening to the wall must have exactly the same fire rating and insulation as what is required of the wall, right? With the exception of protected corridors, protected shafts, and all that, which I'll describe a little bit later. You can have half the fire rating, but that one is only for that purpose, right? So yeah, this is also something that's very, very common out there. A lot of people say, yeah, those half fire rating of the wall, right? They say no. Some people say no, must be entirely the same fire rating as the wall. But then you say, yeah, I heard somewhere that there's this thing half the fire rating. Yeah, very, very confusing. But I'll clarify a bit later. The prescription is actually very, very simple. Once you understand that, but having said that, in a lot of my own projects, I don't specify half rating or full rating. To avoid confusion, I just specify everything as the same fire rating. So if I got a maximum 2-hour fire rating, every single door I specify a 2-hour rating. why put on the trouble, you know, because you're liable, you know, the contractor puts the wrong door, leave to the wrong place, I'll end up being liable. So to avoid that, yeah, I just have one specification. Yeah, you don't tell the owner, he wouldn't know. Yeah. Buy your QS a good lunch so that he wouldn't raise that issue. Yeah, that's right. That's right. Yeah. Well, ultimately, we are the architects. We say so. That's it. You know, no one should challenge it. All right. So okay. So this is the recognition. This practice is not new. This is what it's always been. And by the 2021, we just made it clear that this is the way it should be measured. So we hope that one, from now on, we should solve a lot of the problems. Yeah. Right. So another addition to UBBL 2021 is this. Just to recap with this diagram, we got the travel distance, slowly exit, exit route, final exit, horizontal exit. So this area over here where the final exit is, very, very often, our actual final exit is actually a distance away from what we think was the original final exit. This is particularly prevalent in, say, a hotel or in a commercial high-rise building. The stairs and the lobbies and all that comes down to the lobby. And then you say, so where exactly is the final exit? Your stairs open up. I'm in the lobby. And the lobby got Christmas decorations, etc., etc. So UBBL 2021 addresses this space over here. From your discharge, from the stairs especially, down to the fire appliance access level. And if your final exit is actually a distance away from the exit of that protected shaft, now we call that the path from slowly exit discharge to the final exit. This is where UBBL 212 has come up with new prescriptions. It's in clause 174A under final exit. It's just immediately after 174. They just slotted this additional thing. To make it cut a long story short, it's like this. If you have a simple arrangement, you have the protected stairs coming down. This is the ground floor or the lobby area. You have ground floor where the final exit, the stairs come up, go straight out to the street. Don't get knocked down by a car, but go straight out to the street. And those are the final exits. So the final exits are, that's it. Once you cross this threshold, you're in the final exit. Now, what this new clause does is, it sorts out this area over here. If you're discharging into, say, a courtyard, you're still within the building compound. You still got fences, you still got the main gate somewhere. Or you're discharging into a Medan Selera, or you're discharging into the lobby podium, where you will see that, wow, the owner has rented out all the space for all the hawkers and the kiosks and all these things. Or there's a giant styrofoam Santa Claus decoration, things like that. Okay. Now this is where 174A comes in. It gives you additional prescriptions and what you can do within this space. Now, once you discharge into this space, you have, from this final exit here, you have to go either into a protected and enclosed corridor with the distance and dead end limitations as per the 7th schedule. Or you can go through a sheltered, open-sided corridor, not more than 5 meters within the building E. Okay, I know you'll be wondering what in the world am I talking about here. I also didn't have a clue what it was. So I have to do a bit more investigation. I will describe to you later. Or open to the sky and enclosed corridor with a two-way travel. Essentially, the last one just means if you go to an open courtyard, as long as there's nothing above you and you got two-way travel to an exit, to a final exit. Yeah, so that one is very simple. The first one is also very simple, protected exit corridor. So you come out over here, okay, you you're having a lot of commercial activities over here. So what do? You create a protected corridor. Come out, enter a protected corridor with the travel distance limitations, and go straight up to the exit. Very simple. The last one is, okay, go into an open courtyard area, totally unenclosed, and you can travel in 2 directions to the exit without travel distance limitation. Okay, number 2 is the one that's a little bit funny. Actually, we plucked this straight off from the Singapore Civil Defense Force prescriptions. We really thank the Singaporeans. They're actually very good in terms of their legal logic, in terms of how they write things. So the next slide I'm going to share with you is plucked straight off from the SCDF Code of Practice of Precaution for Building. So number 2, what it really does is it's talking about this. When you have a final exit out into a space that is not exactly fully open, you're allowed up to 5 meters maximum of an overhead enclosure. That means you are not supposed to be under shelter for more than 5 meters. And along this space, you can have commercial activity here or here, but you must be allowed a direct route out. This is probably very applicable to say our 5-foot ways. When you come out here, sometimes our 5-foot ways are occupied by commercial activities or building overhangs and all that, the lobby areas. And some of these lobby areas may not be so straightforward. It may be going in like that, a very giant open one-end lobby. So the idea is that you have to have your discharge out into this space, no more than 5 meters deep from an overhead enclosure. Right, so this one describes what it is. If I just refer to this particular clause here, there are too many inappropriate descriptions. So, inclined building. Okay.
So how do you classify that?
The question is an inclined building. That means the forecourt that you come up is an incline, is it?
Yeah. The building is inclined.
Or the facade is an incline. They're just looking at the final point here. So the building is inclined in this manner, or you're saying the is inversely inclined in this manner. Okay. This Singapore diagram doesn't show that, so I'll say leave it to interpretation again. But sorry. Okay, that one is the next scenario. Okay. Okay, the question was what if the building is an inclined and inversely inclined building, like our the Energy Commission building in Cyberjaya, where the building facade is actually inclined in this manner. So I'll say I don't think the laws can describe so accurately down to the level of detail. I'll just say that it's a matter of interpretation. We are the architects, so the whole purpose of this is that we are designing such that when a person comes out of this, he's not under a risk for more than 5 meters in this situation. Right, so if the building above over here contains aluminum cladding, later on I'll be talking about BSA 414. So if that's kind of a risk, no way. You have to get the people out in another manner. Yeah. Okay. All right. So further on to 174A would be on the enclosed areas that you're exiting from. Just now was on the stairs going into an open area and the limitations of what you have to do. Now is on the stair discharging into an enclosed lobby. So the same concept applies. This should have been the final exit. But however, if the building is designed in this manner, then you'll have the stairs discharging into what is otherwise really an internal space. Right? So the first limitation is that you cannot have more than 50% of the stairs discharging into an internal space. So if you only got 2 stairs, if both stairs and capacity So you have to balance it off. Physical number no more than 50% and capacity also no more than 50%. So if these two stairs share the same capacity from the floors above, only one of them is allowed to discharge into this space. The other one must be outside. So if you have 3 stairs, how do you divide it into 1.5 stairs? No, if you have 3 stairs, then only one is allowed to discharge in, and the 2 must be discharged outside. So it's up to 50%, no more than 50%. Then from here, you have to designate a travel path from the discharge to a final exit. And this one is limited to 10 meters. Is in the bylaw is 174A, subclause 2 and ABCD, one of those. Yeah. Unobstructed passageway. That's right. Okay, this one is both fire protected and non-fire protected. So first is you have to demarcate this particular pathway. And the criteria, one of the criteria written in law, surprisingly, is that the final exit must be visible in the line of sight. When the moment you open the door, you must have a line of sight to be able to see where the final exit is. Right? You designate it. You just designate it. You don't have to mark it on the floor. It's not required for any physical markings. But what you mean is that it has to be line of sight, and you should have a clear path leading to that exit. Sorry. That's why included in this clause is that for you to be able to apply this, you must have sprinklers, number one. Secondly, you must have the smoke control, engineered smoke control. All right, we were talking about the discharge into the addition to clause 174A. This is the second part where the discharge is not into the open, but the discharge into an enclosed space. So the main criteria is that this enclosed space must be sprinkled, and it must have the engineered smoke, the engineered smoke control solutions in accordance to the Malaysian standards. So on the physical criteria on the designing for the discharge, so we say less than 50% of the discharge from the stairs above is allowed to enter this internal space, or maximum 50%. And we'll have to demarcate a clear path of discharge from the stair, from the door, and this will have to be a fire-rated door, because this is a protected stair coming down, and it's discharging. In a way, it's a bit like a horizontal discharge into a secondary space. So that will have to be fire-rated. You'll have to have a clear demarcated path. The condition is that final exit must be within eyesight of the position of discharge from the stair, and you're limited to 10 meters, no more than 10 meters travel distance. Then, as to what else you can do around it, if you're not having any firewalls or compartment walls, you're having any other commercial activities like kiosks, Christmas decorations, anything that may be combustible, you'll have to keep it minimum 10 meters away from this designated path of travel. I know this diagram is not to scale. There's 10 meters travel distance here, limit, and yet I've got a 10-meter buffer here, which appears to be a lot shorter than that. Okay, my apologies. When I was drawing this, then only I realized that I can't exactly get the right scale in place. So, but the written dimensions are the more critical ones. Any commercial activities which is not fire isolated, that means not behind a firewall or not in any compartment, will have to have a minimum 10-meter buffer. And this 10-meter buffer is also very generous. Generally, nobody is going to measure it specifically to where do you measure it to? You know, is a person standing there considered a commercial activity, or is it actually the display of the goods? So that is very vague, right? But the intention is quite clear that if you have a situation where you're discharging into a common lobby, you must allocate a very clear line of discharge route to the final exit. within 10 meters of travel, within line of sight. That means with great clarity, visual clarity as to where the exit is, and keep your commercial activities 10 meters away. So should there be a fire, you will not have undue impact to the people who are exiting from this building. Yeah. Okay. Okay. The question is, within the 10-meter buffer, what can you do there? Well, it says no commercial activity. I suppose a person standing there or a person sitting there is not regarded as a commercial activity. You know? When I say commercial activity, what it means is that any source of potential fire or any fuel, everything is fuel. Even a human body is fuel, right? So that is not regarded as a commercial activity. Commercial activity meaning no cocaine, no selling of goods, no commercial activity, not generally. It's just a description. If this is a mall, as in what most malls are, people are all walking around. You know, there'll be bar stools, there'll be chairs, there'll be landscape areas, perfectly okay. I think they're regarding more in terms of kiosks, hot dog stands, or things like that.
Because of hello, because of maybe commercial pressure, they might do it. What happens then?
Well, once you've designed the building, if you comply with all the laws and you've given adequate instruction manuals to your owner as to how to occupy the space, how to use the building, and maintenance manuals after that, then it becomes the owner's responsibility, really. Once you hand over the building. So if the owner deliberately uses this whole area of commercial activity and totally disregard whatever you've designed, and should anything happens, of course, Bomba will be calling you first to describe. But if you can show them that this is exactly what I've designed, the owners are well aware of it. Here are the instruction manuals. Here are the maintenance manuals that are given to the owner. And oh, I see the owner didn't do the right thing. Okay, then you can assign the blame to whoever is the building management or building maintenance. Yeah. Yes, it is. Yeah. This is precisely the reason why we particularly recognize this situation and turn it into a law. Because enforcement has always been very difficult, and it starts off with our design. When we design it, by not having this prescription, most of us went really very generous. We have situations where the stair is landing into a main lobby area. Then from there, it goes out to a totally covered car park area. And the final exit is going through car park. So you're supposed to have exited from the building above, but you landed in a ground floor car park. Yeah, and then.
So in terms of the detail, when we submit the, as it were, the manual, we have to indicate something like that.
Yes, we have.
Just to, that's really in kind of protecting us, really.
Exactly. Yeah, exactly.
Okay.
And most of these items will have to be indicated in your Bomba plan anyway. When you submit Bomba plan in this particular situation, we do have to indicate the Bomba what was your intention on this part here. It's not required that you do physical markings, but it's just that your plan must show the intention of compliance with this clause.
There's one question. How about going through a hotel lobby?
Exactly. This one applies for hotel lobby or any other lobby. Yeah? So this is exactly the situation that it applies to. Now, so like in a hotel lobby, you'll have, say, the lobby lounge, cafeteria. Those areas will be regarded as commercial area. It's Christmas decoration. Make sure it's not styrofoam. And don't hang cheap Chinese-made LED lights on it. It may just ignite the styrofoam. Yeah. All right. Okay. Now what I do, because as usual, I my compilation of these notes here is actually the entire module 1, 2, 3, and 4. Each module is supposed to be half a day. So all 4 modules here are supposed to be 2 days, 2 full days. As usual, I'm just being very lazy nowadays. I just pack everything in one go, you know. I have not separated it. So what I'll do, because we only got half a day here, I'll just talk with the organizers over here. What I'll do is that I'll go straight into the revisions. Right, so I'll skip all the basic items and go straight into the revisions first. I'll try and cover that before the end of this session. And if necessary for us to go through the entire thing again, we will have to arrange another, maybe a second session to catch up. Okay, so let me just run through. Right, one of the main additional item put into 2021 is with reference to areas of refuge in hospitals, designing for safe evacuation, and in particular for hospitals, the recognition of this area of refuge. So again, before I say that Bomba and ourselves did so much homework when we came up with this clause, let me just say something here. I hope that it's not recorded and don't spread it around. We actually plucked it off again from SCDF, the Singapore Civil Defence Force Codes of Practice. And as usual, when we pluck something off from all that, we will want to put in a local Malaysian flavor. So certain things are taken out and certain things are added in. But as usual, if you got the recipe for spaghetti carbonara and you try to localize it, you'll end up rojak lah. So it may not necessarily be the best, and it may not necessarily have the full essence of what the original intent was, right? But having said that, let's understand what is the purpose. We've had in I think 2016, was it the Sultan Aminah Hospital fire? So that was a trigger to Bomba, because Bomba got a full rap as to why is it that Bomba are not imposing stricter conditions on the safety for hospitals, right? So the this area of refuge thing was taken from SCDF, and I think they've done a very good job. I'll go straight into describing what it is. It is all about evacuation or the safety of occupants. This one doesn't apply to the whole hospital. This one only applies to the patient accommodation. If you're doing an outpatient clinic, or even if you're doing a daycare, a day surgery clinic, this condition does not apply. It only applies to hospitals or facilities where you have overnight stay or long-term stay accommodation after surgery or any of that. So we're referring it to wards. It only applies to wards. Now, whenever you have a ward, then this one applies. So the basic concept is this: when you have a ward, every ward must be serviced by, or every ward must have access to 2 independent areas of refuge. This one brings in the alternative exit again. So every single ward, you must have 2 areas of refuge, and these 2 areas of refuge must be realistic or genuine alternatives, preferably in the opposite part of travel, or at least in a part of travel that that is genuinely an alternative, right? Should one be incapacitated, the other one is available. Right, so in this example, can have a ward here, say a single ward, 2 AORs, 2 areas of refuge on either side. Sorry, I have to put on my pointer. Right, you have a single ward here and 2 alternative areas of refuge. If you have multiple wards, they can share the areas of refuge. It doesn't mean that every ward must have its own set of 2 areas of refuge. It's just that every ward must be able to access 2 alternative areas of refuge. And also you can have multiple wards sharing those areas of refuge. And the second requirement is that ward access to the AOR shall be only via an external corridor, which in this case I've indicated here, from the ward, you go to an external corridor. Just now we were mentioning about the corridor, and there were some discussions offline just now about apartments, front door to protected corridor or to an open corridor concept and all. Okay, it's the same concept applies to this, right? The ward, to get access to the area of refuge, either via an external corridor. If the area of refuge is the distance away from the ward, it doesn't have to be adjacent, right? But you have to go through a safe corridor, or if the wards are adjacent to the area of refuge, you will have to be via either a protected lobby or immediate adjacent horizontal access. So in this case, either you go through a protected lobby, or if it's immediately beside it, then you go through a horizontal access. And each area of refuge is to be served by at least one fire escape bed lift. That is the whole purpose of the area of refuge. The clause itself also specified or prescribes what is the minimum accommodation size of the area of refuge. It doesn't give you a specific description on the actual size, but all it says is that each area of refuge must accommodate 50% of your intended bed capacity. So if the ward carries 50 beds, each area of refuge must be able to accommodate at least 25 beds. And it doesn't even prescribe the size of the bed or how you're supposed to arrange the bed. You are the architect. The UBBL allows you as the architect to decide how do you maneuver the bed in to hold it in the position. What about additional spaces for the attendants, the nurses, and circulation or things like that. So that one, they leave it to us as the architect to decide. To design. The thing is that the areas of refuge is supposed to be a holding area for all the stretchers and the beds. If each area must be at least 50%. Yeah, it just refers to that you go to one area of refuge, okay, you can at least accommodate 50%. Yeah.
So it's like, let's say the two wards going discharging into the two separate AOR, the bottom sample. That means we look at the total bed for the two wards and the AOR must be 50%.
Yes.
Can be one bigger, one smaller.
It can be, but the smaller one must be at least 50%.
Oh, okay. Okay. Okay.
All right, then, and okay, this is the most important thing. Like each area of refuge, for it to qualify as an area of refuge, if it's anything other than the ground floor, it should be served by at least one fire escape bed lift. So that fire escape bed lift. And every fire escape bed lift is to be within a firefighting shaft and adjacent to a protected stair. So this one adds another complication now to the planning. What it says is this: not only is it just a fire escape bed lift, but the fire escape bed lift must be a component of a firefighting access lobby. It says firefighting shaft, but firefighting shaft means firefighting access lobby. Right, so this is where if you remember earlier on, for UBBL 2012 and together with MS 1164 on the access for the disabled, MS 1164 and then captured further in MS 1163 on the evacuation lift, the requirement for evacuation lift for the physically disabled. For the physically challenged. So this is the condition that follows on from that. Now, so if it's within a firefighting shaft, so you say, oh, by the way, if it's really in a firefighting shaft, I got the bomba lift, right? So can I also, like in the same concept with the evacuation lift, can I use the bomba lift as an evacuation lift? And the answer is yes, with conditions. So every fire lift can double as a fire escape bed lift. Fire lift can double up as a fire escape bed lift, but on any floor, you must have at least one of the fire lift to be solely a fire lift. Yeah, you might take some time to figure it out now, but that's exactly what it is. Right? That means fire lifts can double up as fire escape bed lifts. But in any given floor, we have multiple firefighting shafts, multiple firefighting access lobbies. At least one of the lifts, one of the fire lifts has to be solely a fire lift. Right? That means in any given floor. Right? So the idea is this: while you're evacuating the patients, bomber must have at least one fire lift for the entire floor for them to be able to get access up to the floor. If every single fire lift is also doubling up as a fire escape bed lift, bomber will be waiting downstairs while everyone trying to bring all the patients down. Or bomber will have to climb the stairs. So bomber, I say, it's okay, I can make do with just one lift. Just leave me one lift solely for my own use. Yes, there's a question. In this diagram, it should be 3. Yeah, so that means there will be one bomber lift, which is also shared. And then there will be one dedicated bomber lift. And for that particular shaft, you need then a dedicated fire escape lift. Yeah. Solely for bomber. That's correct. Correct. Yeah, because that's exactly what the area of refuge is. If you remember, when I talk about exit routes, I say exit route is a safe passage, which may also go through an area of refuge. So that is specifically what an area of refuge is. Yes. Yeah. Yeah. No. No. This one is specifically for hospitals. 224A is specifically for hospitals with patient accommodation. And this area of refuge is specifically for the areas of what we call the patient accommodation. So it's specifically for wards. It doesn't apply to any other thing. Yeah. Hospitals, institutional purpose group, hospital with patient accommodation, not nursing home. Yes. It's specifically for hospitals. Yeah. But however, having said that, this whole one is designed for patients on the bed. So if you have an institutional nursing home where you actually have got this palliative care where you are caring for patients who are bound on the beds, you would be probably classified under this. Because here it says is what is applied to patient accommodation. Yeah. Multi-story building. Single building, you just push everyone out the door as fast as you can. Open up all the walls and push them out. No, it's any floor above the ground floor. Any floor above the ground floor. That means it applies to any patient accommodation above the ground floor. That means if you cannot push the trolley straight out the window, yeah, you need this one. Yeah. That one is a general application for all buildings. That one is a classification for all buildings. 224A is specifically for hospitals, patient accommodation. But I think it's actually a very good thing. Now, if say you're designing institutions, other kinds of institutions, like say palliative care, it's not a hospital. But if you know you are providing the kind of a care for bedridden patients who are actually going to be there, you may want to apply this one. Because this is the way, this is the difficulty with Bombay are facing now is that they're very aggressive. Okay, 1st of January, all hospitals must be like this. It's like you say, what are you talking about? It's near impossible because this one involves so much physical, structural work. So the application may actually involve the reduction on the capacity of hospitals, say existing hospitals. For you to accommodate all of this, you either build extensions or within the same given floor plate, you start to reduce the capacity for you to accommodate all these extra areas. Right. So yeah, Bombay, I think that you are the architects, you figure it out. Area of refuge. Yeah. It is for that floor, for that floor. Yeah, yeah, yeah.
In the area of refuge, you cannot push all the patients side to side. In fact, we were advised that you have to have access to the patient. So that means, let's say, for example, you got 20 beds in there. You might stack 10 on one side and on the other side. So there's access because the patient still needs care, even though they are in the area of refuge. So therefore, the area of refuge can be quite large. You need to think about access to the patient as well.
The area of refuge, the primary purpose of the area of refuge actually is a buffer while you are evacuating the patients. It's not exactly meant for you to just push the patients in there and leave them there, right? It's actually meant to be a buffer because it takes time. You can only have one patient or one lift at one time. No, there isn't. Oh, fire rating. Yes, there is. I think it's 1 hour or 2. I can't recall. There is. If it's silent, particularly for area of refuge, then you refer to the that for hospitals for your size of hospital. You just refer to that. Yeah. Practically, no. You see, in the ward, the patients, you have the patient's bed, you have the side tables, you have all the other appendages. The AOR is really like a parking space. That's why they do not have a prescription on the minimum size. It's on the performance basis. So you are the architect, you decide how the beds will be shunted in while they evacuate to the lift.
But then the size will be substantial, isn't it?
Sorry?
The size of the AR will be substantial, especially on the upper floor.
It won't. Yeah. Okay. I think let me go to the rest of it. Yeah. Okay. So on the just now I mentioned that to get to the AOR, either through the external corridor or internally through a protected lobby or a direct adjacent access. For the direct adjacent access, it will be a fire separation minimum of 1 hour FRP. Yeah, you mentioned that. Minimum fire, 1 hour FRP. You must have a minimum engineered smoke control, 2.5 meters smoke layer, and minimum 2 exit access located as far apart as practical. So if this is the AOR adjacent to this particular ward, you can literally just go next door. These are like a horizontal exit. Just have the doors. To one AOR also, you must have the 2 separate entrances to be as far apart as possible. This is actually to facilitate more movement. so that you don't queue up over here. You know, you're trying to move it on both sides. Fire rated, 1 hour fire rated, and essentially just a adjacent horizontal access. And this AOR in turn will be connected to the firefighting access lobby. Okay, or in a slightly more complex situations where you have the wards opening up into the nurse stations, into either any other adjacent areas. So the concept is actually much the same. You'll be entering through, in this case, either the external corridor or an internal corridor, which is then protected, or an internal corridor, which is ventilated. Going into a protected lobby, which is like the other case where if you're not going from the ward immediately adjacent into the AOR, you go through a protected lobby, then you go into the AOR. So the separation, if this corridor here is going through a high-risk area, non-ward, high-risk non-ward area, then obviously you'll have to carry the same degree of fire separation. The idea is that this internal corridor acts as the safe corridor to access into a lobby, in turn accessing into the AOR. Safe. This one will be under the hospital concept. Yeah. So again, the definition of horizontal access and all that. Once you go past a compartment, then the travel distance starts measuring on the corridor basis. Yeah, the same thing. All right. And when you have an internal corridor, then if you're not pressurizing the internal corridor, you're allowing for natural ventilation, then minimum compliances of the natural ventilation comes in. Yeah? You need minimum openings, which is far bigger than the ventilation for staircases and the ventilation for corridors. And the whole idea is that it is to get cross ventilation, which is good practice. Really, we should be applying this for all the corridors we design anyway. Yeah, but specifically for hospitals, they do want this to be defined clearly. So the idea is that every single natural opening for natural ventilation must be within 12 meters of any part of the internal corridor. And ideally, they should be placed in such a manner that it can induce cross ventilation. So if you have a far longer corridor, the most ideal location would be, say, 2 at the extreme end, and you have another one in the middle to comply with the 12-meter radial coverage of the opening. That means every single part of the corridor cannot be more than 12 meters away from a natural opening. If you're going for natural ventilation, if you're going for mechanical, then mechanical ventilation and pressurization and smoke control all comes in together. Right, and particularly for hospitals, for areas of refuge, we've now introduced an 11th schedule to the UBBL. We have up to 10, so now it's the 11th schedule. And this 11th schedule sole purpose is for the dimensioning of stair landings for the maneuvering of stretchers or beds of stretchers. The concept is actually very simple. Generally, it controls the depth of the landing. So if you demarcated this stair, basically this will be the stair at the areas of refuge discharging. That would be the stair. So half the people will be waiting for the bed lift. The other half will be attempting to go down the stairs. So the way to run is purely to allow the stretchers to be maneuvered around the landing. So if you've got a narrower stair, you need a deeper landing. If you've got a wider stair, okay, you can have a narrower, a shallower landing. It's just like us you turning our car. You need more depth if it's narrower. Okay, so that one requires a 11 schedule into our UBBL. Okay. That, 3 and 4, that is correct. That is correct. Yeah. Yeah. That's true. That is true. Yeah. The primary thing is, of course, the width is always there. Now the understanding is more on the depth. Right? The narrower the depth, the deeper the landing will have to be to allow the scratchers to come up here and maybe swing again. He may come up here and then this person swings over here. I think it would be unlikely for them to try and do a turn. You'll be for narrow stair, you'll be more like the person who is on the lower stair goes up here and then he takes the position of the higher position and then they swap again at the next landing. Yeah. Yeah, there were never any limits to the height of hospitals. It is always limited only by the functional practicality of designing a hospital. There were never any bylaw limit to the height of hospital. That one is a separate thing. Yeah, Ministry of Health, they will have their own control. Yeah, but as far as bylaw is concerned, we leave it entirely to your technical expertise. Okay. Okay, I will skip evacuation strategies because there's no change on this. I'll just skip all of this. All right, the single stair. Coming back to the single stair. UBBL 2012, we introduced the single stair. That one caused a lot of hoo-ha. And I think now most of us have accepted it. And the limitation was that we limited it to 2 stories. We generally limited it to 2 stories. Right? We limited it to 2 stories and we made a condition that the upper floors can only be used for residential. Ground floor must be shop, but upper floor, no office, cannot, nothing else, just residential. That was the limitation. That was the one that killed all our developers. Okay, now 2012, we just made the clarification. Very simple one. Instead of defining shophouses or dwellings, we are now called buildings. So yay, it's open up again. So you can do your karaoke lounge up there now, right? But then you said, how come? How come you had such a big change of heart? How do we do that? No, it's not so easy. Okay, so the definition last time the old 1984 was like this, up to 4 stories, 12-meter height and all that. So now we're still limiting it to 2 stories, and the uppermost floor only two stories, not 3, not 4, only 2 stories, and the upper story not more than 6 meters from the fire appliance access level, ground level, which is still the same. Only difference is that we're no longer limiting the bottom to shop, limiting upstairs to residential. Now it's do as you like, right? But the condition is this: travel distance, dead end limit, exit capacity, story exit and final exit, and compartments all apply. So if you decide to do a karaoke room up there, okay, we let you have 1 staircase, but you're limited to the exit capacity and you're limited to the travel distance. So if karaoke room is under place of assembly, is it? Okay, there's no dead end limit. So you can't have a single stair if there's no dead end limit. So that's the way they control you. All right, so do as you like. You allow a single stair, but the floor accommodation must be able to be served by a single stair. Travel distance, dead end limit, exit capacity, story exit, and final exit. If you can find a way to make that work with a single stair, you can have that occupancy. All right. So I think it's very fair. I think it's very fair. It's only 2 stories. You're limited to 2 stories. Okay, silent. So don't get caught. Actually, technically you can, because the mezzanine is half the floor, right? As long as you don't do more than half the floor, then it's okay, right? Okay, so this is it. Don't take too much into it. It's really for post-occupancy. It's really a post-occupancy control. When you design it, just design it within the travel distance, within the dead end limit that fits already, you hand over to the developer. Then it'll be a post-occupancy licensing issue. Okay, capacity of exit. Okay, this is where there are some changes to the 7th schedule. We've added in now the controls of capacity exit for storage in general. Before, we never had this. And especially for car parks, we are always been asking, how do we calculate exit capacities for car parking? Right, so we've always used, as a general rule of thumb, we say 2 persons per car. And then we find out that, yeah, mana boleh, where for such thing. So now we've come up with the prescriptions. Generally, 20 gross is double of that of office accommodation. Office is 10 gross, so for car park we use 20 gross. Okay, I will skip through all this. There's no change in this concept. Okay, I'll skip through all of this. No change to this compartmentation, size, and then okay, and fire load, all this has no change. So no change to any of this. All right, the 5th schedule now. Okay, 5th schedule is where we have the purpose groups. Earlier on, I already mentioned that there are just some refinements to the categories of buildings to be placed under the purpose groups. Now, when it comes to the prescriptions, purpose schedule 5 limits the fire compartments of the building. So here, alongside clause 224A, where we talked about the wards, particularly hospital patient accommodation ward, now has got floor area limitation. Right, every ward cannot be bigger than 750 square meters in floor area, and this one is not applicable for the doubling of limits if your building is sprinkled. So this 750 meters is absolute. You sprinkler the building, you're not going to get 1,500. Just particularly for this, not even hospital as a purpose group, is specifically patient accommodation ward only, right? Limited to 750 square meters. So this one, in a way, also limits the number of beds. Yeah, by how they never say how many beds, they don't limit that, but within 750 for us to design. Yeah, it's just to limit that. Yeah, and this is a further, yeah, it's from the same schedule. 750. Okay, okay, all these remain exactly the same. Schedules, all the 9. Okay, all these remain exactly the same in terms of how we are supposed to compartment the building. All these remain exactly the same. 6th schedule, I don't think I want to go into it. This one will be another full day worth of things. Okay, I won't go into all of that. Okay, good. So now we're coming to the protection of the building from fire from floor to floor. This one is just a recap of what we currently already have. Protection of the external spread of fire from floor to floor. We have our prescription under UBBL 149 for the external fire barrier, the vertical barriers, and on the horizontal barrier. And of course, we all know the purpose is that it helps to deflect the flames. The horizontal barriers will deflect the flames, 750 millimeters, I think, minimum. And the vertical barriers, minimum 900 millimeters, will help to act as a flame barrier. The horizontal ones will be a flame deflector, or the vertical ones will be the flame barrier. Now, we have a situation of external cladding, right? We're all fully aware of that already. I don't think I need to show the Grenfell over here. Okay, why not? You just have a look at it again. How do I start? Because the cursor will go into a slide, it becomes a laser pointer. I have to turn off the laser pointer first. All right. Yeah. Okay, sorry, I can't get the video working, but never mind. We are all very familiar with the Grenfell. Go on to YouTube, there are about like 5 million different videos for Grenfell Tower. Suffice to say that it's a very, very disastrous event, very tragic, and it did fast forward our understanding and now the implementations of new laws and regulations regarding how we do external cladding. This is it started off with Bomba issuing in August 2021 a permanent directive on the use of external cladding. Can be summarized in 2 elements over here. For all buildings above 18 meters in height, your external claddings must be subjected to the full-scale BS 8414 test, and it must pass. Right? Then all external cladding for buildings above 18 meters in height must comply with the descriptions of the BS 8414 testing criteria. Anything below 18 meters in height, sorry, it's not anything below 18 meters, right? If any building below 18 meters in height, then you are allowed to use Class O cladding. Any buildings above 18 meters in height, for the entire height of the building, it has to comply with the BS 8414. Now, this is different from our previous description. Our previous description is that anything above 18 meters, Class O. Anything below 18 meters, you can clad it with timber, almost anything. And we limit the plain spread to Class 2 or 3 in some instances. So now it's no more. Right? It's everything minimum Class O, and the building is taller than 80 meters. The entire facade must be full scale BS 8414. So that leads us to UBBL 2021. After the directive, now clause 144 is on that. Again, to cut a long story short, very simple. It just means that if your building is less than 2 meters from the boundary, or your building is more than 18 meters in height, whichever comes first. The cladding system must comply with BS 8414. If you're just 2 meters away from neighbor, I don't know how you can build 2 meters away from your neighbor nowadays, but never mind. If you are 2 meters away from neighbor, okay, don't have anything flammable that will face the neighbor. Or your building is more than 18 meters. So like that, either you're closer or you're more than 18 meters. However, if your building is more than 2 meters from the boundary and it is not more than 18 meters in height, then you may just comply with Class O. So a short building far away from your neighbor, okay, you can comply with Class O. Anything other than that, you have to go for BS 8414. And BS 8414 is really a series of, it's a test. It's a particular testing criteria. It involves the creation of a very, very big size mock-up which reflects every single component that you specify into the system. Most manufacturers, they have a lot of manufacturers, a lot of suppliers, especially the ACP world people, they have taken their own initiative to erect their own detailing specifically to pass this test. Because this test has got very, very precise criteria. You pass the test, you got your license. No? So a lot of manufacturers have gone ahead to devise this detailing, to devise this mock-up for them to pass. The early ones, they go in there, they fail. So they see where are the failures, and then they devise a sample again, and they pass. The criteria is like this. Whatever it is that you specify on your buildings, it has to be exactly the same as the sample that has passed. So if the manufacturer has done a pre-testing and it's passed, and you are specifying his material using his passing standard, you have to ensure that you are using exactly the same components as that guy has designed that pass the test. If you are designing your own components, you're designing your own dimensions, you will have to get the manufacturer to test your design again. That is the criteria. And I did go through this process at a very early stage, just at about, we know it's coming. So I had a bit of a head start in my design, and I worked with the manufacturers. I looked at what are the standard details, and I utilized the standard details. And I only made the variations, architectural variations to the parts that I know will not be affected by the components. Now, so that was how we managed to get a head start to do that. So we must have that awareness. Because you can be fooled. A lot of manufacturers say, okay, I got my system of BFA 414. Then you say, hey, you happily give them the design, and they come back to you with all the details and find there's nothing like what is in the approval. Very, very critical. Okay, this is a series. This one I must show you the video. I hope it plays. Oh dear. Huh? Unshare. Unshare. Okay, we'll just try and top share. Then. Oh, the link is not clear. Was this one actually linked? Okay, never mind. Okay, my apologies. May not be linked because it wasn't from my laptop, so the link may not be here. The link is missing. Okay. Am I sharing the screen again? Am I sharing the screen? No, I'm not. Oh, I'm sharing the wrong screen now. Okay. Okay. Okay, my apologies. I can't run the video because I just realized I transferred it from my laptop onto this laptop, and the link did not get transferred. Never mind. Generally, let's see if I can try to explain it to the next slide. Okay, I'll go to this slide first, then I'll go back to the previous slide. So the text is like this. Okay. This is the full-size mock-up. It's in an L shape. The exact height and the width and this side panel over here, the dimensions are all controlled by the DS8414 testing standard. That means all samples that we send for testing is tested exactly to the same external dimensions. The sample cannot be smaller and the sample cannot be bigger. That is the way they ensure that the testing criteria is exactly the same for every single component. Down here is the fire, and even the size of the fire, the type of wood, and how many stacks are controlled. So that means every single test would be carried out using exactly the same fire load. That just to ensure it's consistent. So you see, when you test something consistently, of course, we have to test something consistently to the same set of standards, right? But once you know the specific set of parameters required for the test, it is also an opportunity for you to design a sample that will only work for that particular situation. This is the reality of life. You can't help it, but that is what it means. So after the test, the test will have a few criteria. You'll have a time limit. I think the test is 30 minutes or 45 minutes, I can't recall now, but there is a time limit. At the end of the time limit, the fire will be doused, and then they'll start recording. But the test can also be stopped if any of the criteria of the test, if the sample fails any of the criteria of the test along the way. The moment it fails one criteria, okay, that's it. The test will stop. That means it's either you fail or you reach the end of the testing limit, whichever comes first. Hopefully you reach the end of the testing limit, and that means you're on the way to passing. Right? And then, particularly for Malaysia, we have added in 2 more criteria to the test. And that is in terms of this thing. Yeah, we call this a pit collapse zone. Right, so we added 2 more criteria here. One is the physical structural failure. If this thing collapses, the test also fails. And second criteria is that anything that collapses, or even if it doesn't collapse, but all this debris, when it falls to the ground, it falls outside this demarcated creep zone, it also fails. Right? This is for the protection of the fire appliance access. If you recall now, the new fire appliance access way demarcation is that you need to have a minimum 2 meters edge before you start measuring the actual width of the fire appliance access. This is the reason. This creep is measured only 1.5 meters. So anything that falls outside the 1.5 meter, this system fails. Right? So the minimum edge that we have now incorporated in the access way is actually for this purpose, so that we are assured that anything that falls will be well within the minimum 2 meter edge from where you measure the fire appliance. Okay, so that's the mechanical performance and the burning debris and full fire. This one is unique to Malaysia. So we say we are not that bad, we are even, we impose higher standards than OT. Okay, then we go on to the atrium. Okay, I'll skip all of this now because this one is exactly the same as 2012. All right, protected shafts. There was a question earlier about the full fire rating for doors and the half-hour fire rating. So just to very quickly recap, this is a cross-sectional area of maybe a compartment and then a party wall and the slab. So all these the lines in green are required FRP. Let's just say 1. If the required FRP is 1, all this will be 1. And all these penetrations have to be fire stopped, and we have to also perform up to the requirement of 1. If you have a fire barrier, if you have a fire damper, for this duct, you also require FRP of 1. But you can have, say, if you insulate or you protect the entire duct over its entire length, say this is a critical, okay, let's just say this is actually the smoke exhaust ducting. You wouldn't want a smoke exhaust ducting to be protected by a fire damper, do you? Well, because it's counterproductive to what a smoke exhaust duct is. Right? So for situations like that, you can protect, or you should. The only way to do it is that you protect the entire duct over its entire length. And this protection can then be half of the FRP. And so if you're putting a damper in this manner, the damper must be of the same required FRP as the wall. Right? However, if you do the protection by the fire insulated duct all the way through, that ducting itself can be half the required FRP. Same thing goes with the vertical penetration. If you have all this penetration and creating a shaft over here, technically this cover for the shaft, this enclosure for the shaft can be half of the required FRP, which is why if you do a door here, of course, if you do the wall and all that, the walls will be the same FRP as the structure. But the moment you put a door, the door can be half the required FRP. If you do a full FRP structure, of course, you don't reduce the wall. Now the wall will be full FRP. But again, when you have protection like this, when you have a separation of fire dampers for the vertical shaft connecting the floors, these may be half the required FRP. And on the same note, if you have a door opening into the shaft or into a protected corridor, it can be half the required FRP. Okay, so what is the logic? Okay, if you just look at it that way, some experts may not agree with my logic, but I think that's the easiest way for us to understand why. Simply because if this is a protected shaft, if your requirement is 2 hours, so if you start a fire over here, you expect the fire you expect this wall to hold back 2 hours worth of a fire. In a situation like this, the connecting fire is through this shaft. So if I burn over here, I have 1 hour protection before the shaft gets burned, and I have another 1 hour protection before the shaft burns back into this compartment. Okay, that is the logic. That's why you allow half the fire protection when you have a protected shaft or a protected corridor. So when it comes back to that protected exit, you can have half the fire rating. Okay, now fire shutters. Okay, fire shutters. This one again was as I mentioned just now, all protection of openings through a fire rated structure or fire rated element must have the same fire rating protection, or half in the case of through a protected shaft. But however, insulation is something that we've always not considered. When we talk about fire rating, we're really only talking about the integrity of the material, that it holds back the fire. 1 hour fire rating or 2 hour fire rating, the material has got integrity. It holds back the fire for 2 hours before the thing disintegrates. However, insulation is also one of the criteria. You recall the 3-stroke numbers. First one is stability for structure. Sorry, first one is integrity for the material. Second one is stability for the structure, and the third number is insulation. So in the fire shelter situation, indoors, now all doors are tested for this MS1703. All doors are tested for fire rating and also insulation, right? So now we're also applying it to fire shelters. So when you have a fire shelter installed in as a protection to a compartment wall, you must also have the corresponding insulation criteria, right, for compartment wall. So fire shelters with integrity and insulation fire rating may be used as a compartment wall. So the whole shutter can be a compartment wall itself. That's what we did for some of our industrial ballroom concepts, where the entire space will open up, but within the compartment limit, we have this insulated fire shutters hanging up in the air. The moment there's a fire, all these shutters come down and it suddenly becomes a wall. Now, when it's open, the whole place looks like a ballroom. So you can use that. But you cannot use a fire shutter as a compartment wall in fire command centers, protected lobbies, or protected exit routes, including stairs and corridors. What it means is that you may use the fire shutters as a compartment wall for your functional criteria, but you cannot use a fire shutter as a means of protection for anything related to exit and firefighting lobbies. And that means those are the hard areas. The hard areas must be protected permanently. You cannot have a shutter acting as a wall. However, all those walls, the permanent fire-rated walls that you're not allowed to use a fire shutter as a wall, you also have opening. And of course, you can protect those openings with the fire shutter. Yeah, it's just that you cannot use it. The entire wall cannot be made up of a shutter. You must have a wall first. That is why it's not prescribed. So how big is your shutter before it becomes a wall? Yeah, how big is your shutter before it becomes a wall? I have a nip wall, it's a wall, but the rest of it is a shutter. Okay, I think that one is open for debate. Yeah, but the intention is this, that you cannot rely on a mechanical element to protect critical things like a fire command center, protected lobby, and a protected exit route and stairs. Okay, protection of opening on doorway on the compartment floor. Okay. However, a fire shutter need not be insulated. This is the concession that we sort of agreed with Bomba. We know a lot of our car park, we already installed fire shutters for 20 over years. All these heavy galvanized shutters, very good. But every time there's a fire, it goes glowing red hot, and you can cook a chicken on the other side, right? So, and yeah, the thing with our developers come in again, all these speculative developers, cost and all that comes back in. So there is a concession that we recognize. If the shutter is only separating a fire compartment from one habitable area to a non-habitable area, or between two non-habitable areas where there's no risk of the radial, where there's no fire load, where there's no risk where the radial temperature can ignite a fire on the other side, okay, you may use a fire shutter without insulation. So this is particularly at edge of atria or void or escalator void areas, car park driveways, right? This one may not need to have insulation. I think the most obvious example would be, say, in a car park. If you have a car park driveway, there's no car park on either side anyway. It's going to be a driveway. So should there be a fire over here, this thing will be burning red hot, but there will not be any fire load on the other side for it to catch a fire. And likewise, like an atrium, if you're so high up there, there's no fire load because there physically isn't a floor over here. So if this floor is burning, you get a lot of radiant heat in here, but it's radiant heat into the atrium. It will not, hopefully, it will not ignite any fire load. Okay, so this is the concession. But I'll say be very, very careful when you do this thing. Please don't save the money for your client if you don't have to. Car parks, I fully agree. Driveways, why in the world do you want to waste an insulated shutter on the driveway? I fully agree. But when it comes to atriums, void escalators and all that, when you're in an internal space, do think a bit seriously about it. Because this is just a general prescription. But when you design, you know your building best. So I would say, don't be too quick to save money for your client. Okay, I don't think the videos will work either. This one here, I'm just showing an example of the installation of fire shutter in one of our projects. This one is an office area. This is actually the boardroom. The boardroom, and they got a full height acrylic, full height, full width acrylic window that overlooks their production area. So when they're having a boardroom here, they can watch everyone producing the money for the directors. Of course, between the factory and the office, it must have a fire shutter. So the insulated shutter is hidden above this bulkhead over here. It's a full big panel, fantastic. When it comes down, it totally shuts off everything and fully insulated. And when we open up, it's a full height, full width view panel. Oh, it works. Wow. What happened? Okay, this is when it's opening. When it's closing, it's the exact opposite of this. Okay. This one is from one particular manufacturer. I shall not give them the benefit of free advertising here, but I think you all know who it is. So the panels come down and they're not roller shutters. They are actually just panels. They'll drop down one at a time and they stack themselves up like Lego when it's closed. Okay. Then these are the more conventional ones, which are non-fire rated, but we know it's applied onto driveway. Perfectly okay. There's no fire load. This one is one example. Something seems to be missing over there. And this building has got CF, it's got bomber infection, it's got FCs everywhere. Yeah, and okay, some of these applications, these ones here, if you follow the bylaw strictly, these ones here do not need to be insulated because this is a car driveway. But then this is a lobby, okay? This is a common lobby. So I think the question comes, right? Do you actually want to? Yeah, again, if you say that, so yeah, okay, technically you look at it, okay, what is the risk? Probably not much because there's an atrium in there. This is the escalator void. And yeah, there are no commercial kiosks over there. No one's burning satay in there, that kind of a thing. So I would say, okay, you may be able to get away with it. Yeah, but do consider when you do your design, you are the architect, so you know the building best. You know exactly what is the function, how is it supposed to perform. I'll say do the right thing. Don't worry about the client first. They got money. If they don't have money to pay for this, they don't have money to pay your fees either. So don't worry about that. Do your job right. Okay, examples of the ducting that I was talking about. The half of the required FRP is to do the full fire rated ducting for the ducts. How are we doing for time? 12:30. Oh dear. Okay, let's see if I can just find a few more things. Okay. Okay, let's go to the 10 schedule. Okay, I'll highlight the specific things that we have now put into the 10 schedule, which is very, 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 very important. The first one is this: small residential building. Bombard doesn't care about small residential buildings. Our King's Palace is also a single residential building. So there's no category to cater for that. Anyway, what it says is that for small residential building, private dwellings of more than 2 stories shall now be subjected to the installation of a self-contained smoke detector. In UBBL 2012, we put it that we actually prescribe that you must have a self-contained smoke detector on top of the stairway. So that one raises a lot of questions. Why on top of the stairway? Why not in the bedroom? You should alert people in the bedroom, isn't it? Wake them up if there's a fire or whatever. By the time the heat and smoke get to the stairway, it's too late. The whole building is already engulfed in fire. But never mind. For this purpose now, we've just changed the note a little bit. Now it's called Note 7. And basically that for any residential building more than 3 stories, i.e. the big mansions, the big bungalows, you should have self-contained smoke detectors installed in the building. And in terms of how it's to be installed and the criteria, refer to MS 1745. Just refer to 1745. 1745 all the standards dictating which are the areas and what kind of smoke detectors to what degree of sensitivity, smoke or heat, to the different areas of interest. So just refer to the standard rather than having the bylaw describing exactly what you need to do. And I think again, it's something worthwhile. Private dwelling more than 2 stories, presumably you can afford it. So don't worry about the client. If he's got ambitions to build a private dwelling more than 3 stories, we'll just assume that he's got the money. If he hasn't got the money for safety installations like this, he's got no money to pay you. So don't bother, don't do his job. It's a bit like buying a car. If you sell a car and the dealer says, okay, for the airbags, you have to add in 5,000 ringgit. Nobody will buy the airbag. But if you sell him a luxury car, say, oh, this car is $200,000, it's got airbags and all that all included, he will buy it. Why? You say, yeah, I'm paying 250,000. Why? My car got airbags, I'm safer. I think it's all about psychology, how we deal with your client. Okay, then. Okay, hospital patient accommodation, just now we mentioned. So particularly patient accommodation wards is now specifically defined in the 10th schedule together with all the necessary active allocation. Right. So again, the main thing is 750 square meters, and that one is rationalized in the 5th schedule also on the limitations of compartmentation. And this one, again, I have to emphasize, particularly for hospital patient accommodation, this 750 square meters is not subject to the doubling of volume if you have sprinklers. This is absolute, right? Just for this classification. And okay, good. Now, the one that we're all waiting for, all our developers are eagerly waiting for this. Apartments or flats, tall apartments. Any building more than 40 stories or exceeding 120 meters in height now will have sprinklers. All residential buildings. And again, it's the same concept. You're designing such a high-rise building, presumably you charge an extra 10% for every floor that you go up. Yeah, you get sprinklers up. You're buying a luxury apartment with sprinkler. Okay, so it applies to both open corridor design or to the internal core design, both. Now, once it's more than 40 stories or above 120 meters. Everything. Because it's quite meaningless if it, yeah, if the guys who are living in the 40 floors below, they are the low class guys. The penthouse gets sprinklers. No, it doesn't work that way. The idea, Bomba, actually we were also struggling. We were arguing why 120 meters? Why not 80 meters? Why not 40 meters? Why 40 stories? Why not 39? Why not 38 stories? But ultimately it came to the stack of the risers. Risers, the engineers were working day and night with Bomba, agreeing on the maximum limit of the riser stacks based on the capacity of the pump sets and the pressure valves and all those things. So 120 meters coincide with 2 stacks of the riser, 60-60. right? So they just have to find a number, a common number to be able to draw a threshold. That is what prescriptive building codes are. So, okay, we agree that 40 stories and 120 meters becomes a threshold. So now we'll see a lot of buildings with, you'll see a lot of apartment buildings now with 39 stories and a double-story penthouse. Or maximum height 119, 119 meters. Okay. And also the recognition of service apartments now. Right, so the term service apartment is now defined and it is included in the plan schedule. And again, the same prescription applies. For service apartment now, because it's regarded more like a hotel. So it's above 10 stories or exceeding 30 meters in height, you must have sprinklers. Right, so now the definition has to be made very clear now. No more ambiguity by the developers. Submit building plan, ini apartment saja. Sales and purchase, or the service apartment or hotel facility. All right, no more. Define it from day one. What is it? And we as architects take the key role. We say we have to design a building for you. Are we designing you? Are we designing you a minibus, or are we designing for you a luxury MPV? Tell us now, so that your direction can be very clear. Just additional clarification for the plan schedule for hawker centers, food courts, etc., etc. Essentially, this is about the installation of hose reels. Not too difficult. Large single-story factories, there's a certain control now. Previously, single-story factories are like free for all. Yeah, there's no limitations where people build sheds and all that. But now, of course, single-story factories are becoming very sophisticated. So we introduced this control over here. Now, with the exception of we're still keeping the open structure design for this purpose. So if you are actually building an open structure shed for metal fabrication and all that, okay, you can go on the lesser just hose reels only and with a pressurized hydrants. For car parking, now we particularly also put it in. Now, previously the definition was either open structure or underground car park. Right, so people are saying that open structure, of course, we got the definition of what makes an open structure. No? So a lot of people say, oh, I cannot meet the definition of open structure, but my car is above ground. It's not underground. So what do I do? Right, so now we just make it very clear. If for whatever reason your above ground car park, you cannot meet the criteria of an open structure, you just refer it as an enclosed car park. Just purely for that. And it is nothing to do with smoke control. It is nothing to do with ventilation requirement. It is specifically only related to the plan schedule in terms of the installation of the active system. Smoke control, you still have to comply. Ventilation, you still have to comply. This open structure design is only for this privilege. If you've got an open structure, basically you do not need sprinklers. But if you do not comply with the open structure criteria, when you reach more than 2,000 square meters, you will need sprinklers. That is all. It is only for this purpose. Automated are like the mechanical car parking, the rotisserie or the fully mechanical robotic car parking. They work on a few concepts. Most of them is that you deposit the car at the bottom and the conveyors will pick up your car and lift it up. Some of them are like normal car parking when you drive around. It's only mechanized at the point of parking when they stack your car up and down on the particular point. But this one applies to all. Generally, the moment it's mechanical or otherwise, above 2,000 square meters, you need to sprinkle it. Okay, and then of course, the open structure criteria from 2012 is carried over, except that they also added one more definition called open-sided. This one is particularly for warehouse. There is a description for warehouse, where an open-sided warehouse, you've got the privilege of not having to use sprinklers for a single storage open warehouse. Okay, so then as to how we comply with open structure, open corridors, we've gone through all of this already, so we're all very familiar. Only thing is, when it comes to that extra definition of open-sided, it is when you arrange your opening on all 4 sides, then it's called open-sided. So it's an additional criteria. For it to qualify as open site, you must first qualify for open structure. Then you have it on all 4 sides, then it's called open-sided. Actually, kind of easy. You're just building on the same definition. Okay, open corridor we mentioned already. So this is fine. And again, all these open corridor definitions, this is not to replace smoke control. It is not to replace smoke control. It is not even to replace your ventilation requirement. The sole purpose of this definition is exactly coming back to the 10th schedule for the installation of active systems. That is all. A lot of times, a lot of confusion. Even Bombard themselves has a lot of confusion. They say open. Once I achieve open corridor, okay, you got fire, your smoke control. No, it never says that. Smoke control is under MS 1780. As long as you comply within MS 1780, you need to have smoke control and all the parameters of smoke control. This description is purely for the purpose of active systems. So like a factory, if you got an open structure design, you find that for this factory, steel fabrication and all that, you don't need any active insulation. But if you do not comply with the open structure design, you end up over here. Say if you're doing a single story structure, not an open structure design, then you got requirement for active system, hose wheels, and all the way to sprinklers. The same thing goes with car parking. If you've got an open structure design, any size, you only require hose wheels. Yeah, but if you do not comply with the open structure design, you will need sprinklers, as we've mentioned just now, and so on and so forth. Same with institutional buildings, whether it's an open corridor design or other design, you'll find that the requirement of a sprinkler is always there when your building exceeds a certain height. When your building exceeds a certain, right? So smoke control has got nothing to do with that open structure or open corridor design. Smoke control comes back under MS under UBBL 241 and under MS 1780. All right, now this is where there's another change from 2012 and now 2021. In 2012, we say that all smoke control systems must be installed in accordance with MS 1780. And this is MS 1780. So MS 1780, among other things, it says smoke control system for areas, any area exceeding 1,000 square meters. Now, in the UBBL 2021, under clause 249, it decided that UBBL, any compartment which exceeds 2,000 square meters shall be installed with smoke control systems in accordance with MS 1780. Right, so we all can breathe a sigh of relief now because the limit is now extended to 2,000 square meters. This one arose because we have a lot of office buildings, tall office buildings, which are now undergoing FC and all that, and we find that what's the common floor plate of an average, say, a high-rise office building? 800, 900 to 1,002, 1,003 square meters kind of a floor plate, right? The center core building, that kind of a thing. So that's exactly the problem. Bombard is finding it almost impossible now to enforce Malaysian standards 1780 on a lot of buildings that have been built. a lot of those buildings do not have smoke control. And a lot of them even went to the extent of having openable windows as part of their smoke control. In an office building, aircon, openable windows. And a lot of times these things have got an Allen key lock, So say in the event of fire, what are you supposed to do? Find the Allen key to open the window, So Bombard realized that and they figured that, okay, I think it's still safe, especially in an office environment. So they increased the threshold now to 2,000 square meters. Yeah. Of course, the standard still say 1,000, but standard is a standard. Right? The law is a law. The law says you may now, you may not need to have smoke control for any areas less than 2,000. Okay, protection of stairs and lobbies. Okay, this is much the same as before. Much the same as before. Buildings above 18 meters, you need a protected lobby for any protected stair, which does not have full ventilation. And for buildings above 45 meters, not only you need to have the protected lobby, but you also need pressurization on the protected lobby. Yeah. But if you have a stair which is fully open to the external side, you're free. You don't need to do any additional protection. Okay, hose reels. So there's much work has been done on hose reels. The bylaw has never defined how we set up hose reels. Hose reels has always been under the mechanical system guide. You say you're supposed to provide hose reels coverage 800 square meters, 800 square meters? 800 square meters, coverage and all that. Yeah, mechanical engineers, they'll be able to do coverage by air duct and all that, but you ask them to put a hose reel there, how to cover, where to put the hose reel. We are the ones to do all the hose reel. That's why you always get it wrong, always get Bombard scolding. So now we've actually even prior to 2021, we were already having a lot of chat with Bombard, but we got 2021 clause 226A, where all hose reel installation refer to the 10 schedule for the application and refer to MS 1489 for how you install hose reels and the standards associated with it. So MS 1489 is now undergoing revision, and a lot of the things we spoke about now is now being channeled into the MS 1489 revision, but it is not out yet. So as an interim period, Bombard is issuing this guideline or this circular. Just as this is purely as an interim thing until MS 1489 is the revision is issued. But you can use this guideline as a basis. Generally, it's talking about the radial coverage of the hose reel now. Currently, we are still using 30 meters. We were actually fighting for 36 meters because you hold the hose reel at the end, the punchutan would be 6 meters. Now Bombard said, no lah, come on lah, guys. Okay, we won't quibble over the 6 meters. So we're still keeping to 30 meters. But I suspect MS 1486 we will be going for 36. So I don't want to say anything yet. Let's see what happens when MS 1486 comes out with the revision. Okay, for now, the guideline says 30 meters. And that in any case, Bombard still wants to limit the point to point. Last time, Bombard has been saying point to point is 30 meters, and that was the one that threw all of us out into a frenzy. But now Bombard agreed if you use the 30-meter coverage, and we proved to them in the diagrams, and we agreed that okay, as the furthermost point-to-point location, it shall be 48 meters. And in any case, us as architects, when we design something, we have to show proof of coverage, actual coverage. So this is how we came up with Bombard, how they came up with this particular directive. This is dated 15th of August, just very recent. They rushed out this one because there's too much pressure on them already. So it's good. They're very responsive. So we gave them the diagrams and they happily used it. And then I realized later they actually used the wrong diagram. a lot of it is work in progress. You know, when we're doing discussions, we are busy sketching and all these things. So the idea is there, but it will take us some time to go back and get the actual diagram set up properly. You know, but
Hello, hello.
okay, my apologies. I've been speaking mute. Okay, so this is the general diagram. We can use this as a starting point now for all our applications. I've also followed it up, which is not in the guidelines of course, but I also followed up with all these our own diagrams. And these I will say will be us architects, we can use this as our own basis to do the evaluations. If you have a simple room like this or area like this, if I put a hose wheel right in single hose wheel to do the job in this manner. But of course, we don't have hose wheels right in the middle of the room. We'll have hose wheels on two other sides. So if you position a hose wheel over there and another hose wheel over here, like you'll find that, okay, this one covers the same. Now, this is where the engineers don't want to get too long because they say that one hose wheel, 800 square meters. So you got 800 square meters, one hose wheel, right? But you have to struggle to figure out when from the engineer look for us. Okay. With this same diagram, position there, hose wheel position there. A little bit to that corner and the other hose wheel to this corner. And this is now engineers are very happy. Good, Mr. Architect. Now you guys sort it out. They're very happy. They're really, really happy that we took this over. For the base will no longer be sufficient. Right? Because those areas because it's now separated by the wall. So in this situation, I say, oh yeah, I better put the hose wheel in the middle so that I can cover. It's not working either. It's working, but they can't hear it. Okay, I will continue. Can you guys hear? Okay, good. Right, so again, using the same diagram in this situation, if this partition is not all the way through, I actually have an opening here using the same hose seal arrangement. So that hose seal will be the cover up to there, and this hole reel on the bottom will be a cover up to there. So this hole reel, because of the opening, is able to cover that space, but it will still leave the area uncovered. So let's use this as a basic principle to check our hose reel locations. Pending MS1486, the revision coming out. Let's just do this. I think as long as you prove the bomba, now bomba, because of this, now they will start to ask you now to actually show proof of coverage hose reel. Yeah, a very good question. We haven't thought about that. The hose reels are really first aid. It's meant for first occupants to use. I suppose we just have to look at it this way, that if the occupant is in there and he has to reach the hose reel quite right, it's still going to be, if it's at the other compartment, is he actually going to run this compartment to look for the hose reel, pull it through the fires out to find fire of this compartment? Probably not. So I think we have to look at it from a functional perspective. I don't think we're in a position to put in words, or especially in law, every single situation. Let's just look at it now, look at the practical aspect. What actually Bomba is really highlighting here is that very often we do speculative office, and a lot of our buildings are speculative office. So we may have used this diagram very happily to come up with a hose reel position. Then the partitions come in. Yeah, so this is where Bomba is trying to make us aware our submission of the plan to Japan Malaman that we do post CF for the internal renovation. Bomba wants to do this. That you same thing like this, that you do not put partition, not box up. You may have a hose reel being ended up located in Andy's office, for example. The hose reel is at one corner. You put the Andy's office there, he's got full control over the hose reel of himself. So Bomba do not want to change it like that. So let's be very mindful of these things. Right, firefighting access. Okay, I think these are. This one have no change to 2012. Only thing is we rationalized the access road gradient. It was 1.8. 1:8 maximum gradient, because we pinch it again 100% of the SCPF cost like this. Yeah, okay, we rationalize it to 1:9. Big jump. I think that's great. There's no other change to any of this. Okay, all this remains exactly the same as before. Okay, perhaps just a bit of a highlight over here. Our UBBL is still basing the portion of perimeter access to the building volume. But in Singapore, they've actually moved on already. In Singapore now, it's both building volumes, and for certain purpose groups, they also base it on floor plate, size and dimension of the floor plate. And I'll illustrate just a simple illustration for our awareness. If we base it on volume, for a high-rise building, for example, a building which is 30 meters by 50 meters in floor plate and 30 meters high, by this volume is 27,000 cubic meters. And our bylaw says you need 1/6 of the perimeter for fire fighting. So that's for 1.6. Now, if I increase the building, if I double the volume of the building, and in this is going higher, I need to then have 1/4. So 1/4 means I'll just extend the perimeter access by 1/4. So that becomes 1/4. If I keep going on and on and on until it reaches an island site. By the time it reaches an island site, this building of such a small office plate and such a small floor plate will have reached 150 meters height before I require an island site. So if you look at it in this situation, if there's a fire occurring in that on the upper floor, that corner of the building, what difference would the perimeter access make? How would it help firemen in any way for them to have this perimeter? But generally, for all buildings, really risers, half of this building. So firemen will not quite look at the inside. High-rise. Therefore, the access, the perimeter access for all kinds of firemen then get access to the firefighting shop. Now, my personal opinion is that the requirement of the appliance access, just because we're going by building volume, the tall building exactly. I'm not saying don't do it. Don't do it. That's what design that comment that is really things by all means. But we have to understand what is the purpose. I'll give another illustration. Just comparatively between a tall building and horizontal building with the same volume. So that one 1/6 of a perimeter stacked up tall. This one goes up sideways. The building will be this long, and 1/6 of the perimeter is long. And this one 1/6 of the perimeter. Right? If I go up bigger volume, this building, this long building will end up being this long. And this bigger volume, I need 1/4. Well, 1/4, I can do it just like that. Just a little bit of extension, I maybe do it 1/4. But this one, for me to fill 1/4 of the perimeter, that is all. I just need to extend the perimeter access just this little bit, and I'm ready to fulfill the 1/4 requirement of the perimeter. But the building is so long. So here, if I have a fire at the corner, isn't that a bit too far? Because this is a horizontal building. It's not a vertical building. We don't have an internal firefighting shaft. How is the fireman going to reach that corner of the building? You comply fully with bylaws, right? But you can't reach. This is probably the next thing we're trying to get into now. Maybe in another 10 years, the way we are going. And also in terms of the configuration of fire appliance access, on the contrary, we are saying that tall building or everyone is saying minimum fire appliance access. But really, if we have a lower building with a deeper floor plan, you would actually need a lot more width to the fire appliance access than say a comparatively tall building because of the way they reach the skylights. And if you look at the Singapore Fire Code, I'm not saying refer to this. Please don't bring the Singapore Fire Code to Vietnam. They will kill you. But I'm just using it as a reference because here they recognize that there are certain building types that you cannot just use the volume to determine the reach of the fire access. Right? They're going by floor plates. So as an illustration, the illustration that we had just now, if we're using the local fire codes, our local UBBL, by volume alone, I need 1/4, and this is the extent of the fire appliance coverage legally. That's all I need. Right? If I use the Singapore code, where they go by floor plate area, 5,200 square meters, they need half of the perimeter for fire appliance factor. And this thing means if I fire there, half of the perimeter is fire access reaches. This is Singapore code. Right? So this is purely an illustration. We are not in Singapore. I don't think we want to move to Singapore, but when we design our building, let us take the next step. Let's take another step forward. Yeah, because when we start to do this thing for Bomba, all this time, Bomba's biggest problem with us architects like that. Why are you guys always, not only are you guys not complying with the minimum requirement, we are always asking the waivers that is less. That is Bomba's problem. Never have Bomba said, oh, architects are so good. The building here, you're proposing extra sprinklers, you're proposing extra perimeter access, I even 12 meter wide perimeter access, not even 6 meters. Never. From what frustration to the fact, never ever propose anything to them. It's always Bomba. Can I not do this? Can I not do that? Can I not do this? Ask the client. So I think as we go on design, let's be aware of all these. We can always start. Yeah, we can always start. That's why they're very, very appreciative and all our working group go in there. We're saying that look, really architects, we've got very, very good intentions in mind, but our problem is the client. Right? So we've got a common enemy. And because of that, then they're very friendly with us. They say, oh, how do we work our bylaws? I see you put in the bylaws, the client cannot object immediately. That's why we start introducing all these things. So in a way, it's helped us by making the bylaws a bit clearer and more definitive. It helps us. We just go to the client and sorry, we can't do that. And ask Bomba for waiver or not. You go and ask, I'm not going to ask for you. That kind of a thing. So okay, okay, I think we've gone way for a long time. Okay, I think I'll skip all of this. Let's see if there's any other thing. Yeah, all these are remain the same. We just made a lot more clarity. We've added more descriptions, clauses, describe all this. These are all the things that I presented to you guys for 2012. But now, yeah, the new laws now have got added clarity for all this. So now, yeah, we can confidently tell the client, I'm sorry, now it's now the law. It's not our own suka kind of an interpretation. Okay, so okay. Yeah, I think that one should bring us to the end. Okay, so just as a parting note, are we still designing to minimum prescriptions? Let's not do that. Okay, let's go forward. Let's help Bomba to help us so that we can deliver better building for our very stringy client. Okay, thank you very much, man.
Thank you, Lisa. Yeah. Oh, and another instruction now. Can they drag 15 minutes? Let us clear some of the Q&A from the Zoom meeting. We'll share that. I will do it quickly. But yeah, we tell them to delay 15 minutes so that we can wrap up. Yeah. 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 We will take some questions from the so everyone can see, and some are not very related. I will control that. This is This one, I can dismiss that by output. Any firm discussion yet from Bomba whether the UBBL will affect plan approvals?
Okay, I can answer.
I can say.
Is it on? Yeah, okay. Bomba's intention is the implementation of UBBL 2021, 1st of January 2023. So it's 4 weeks away. But how are they going to do it? I'm not too sure. And Bomba themselves are also probably not too sure. Maybe they know something we don't know, but yeah, we will want to wait for them to issue a definite guideline or directive or some sort of. So we are waiting for Bomba for that.
I think it was a post earlier, should the 10-meter path as a minimum width.
Okay,
is
so
related
this
to
one
the
related to
50%.
the final exit through the lobby. Yes. That path will have to be of the capacity of the stair discharging into into the corridor. Yeah, because it's taken from the exit door of the protected stair. So it should be the end capacity of the stair.
A similar way to that. side.
Similarly,
The next one is when we were talking about the hospital, is a confinement center under institutional purpose. I think similar to that palliative care thing.
yes.
Is it applicable if it's confinement center?
Yes, as long as it contains accommodation for bedridden patients or occupants. Confinement. Actually, mothers are walking around now. Yeah, you're right. You're right. but a confinement, they do have the maternity ward. So if it's a ward in the hospital, then it falls under this occupation. Yeah. Okay. Right. So it's actually not a hospital. So if it's not a hospital, then this is not patient accommodation in the hospital. Hotel, correct. Yes, yeah.
Yeah, the next one, what is the requirement for natural ventilation to corridor of other buildings other than
This one is under the baseline ventilation requirements, staircase, corridors, firefighting access lobby is added on into the clause for firefighting access lobby, the 240 or something. Yeah, but it's under space light and ventilation. It's in the part space light and ventilation part 3. Part 3 or 4. So that's a standard ventilation requirement, not specific for firefighting purposes.
so the best is to read through all UBBL?
Of course, that's what the UBBL is all about. Yeah,
The best answer, right?
I think while there's so much emphasis on firefighting, right, and I've always said that part 7 and part 8 is really more than 2/3 of the UBBL. Really, we must not neglect part 1, 2, 3, 4, 5, all the way to part 6, because that one also covers CCC, our obligation, constructional requirements, space side ventilation, things like that. Yeah, let's not neglect that. It's not entirely.
Yeah, the next one, the space standards for calculating occupancy loads in bylaw 180 is rather brief compared to SCPS. Is there a more comprehensive list?
Yes. We have to still rely on our current standard. We have not gone into SCPF. Like I said, we're always referring to SCPF when we get into our discussion groups, because they are our nearest neighbor and the applications are probably closest to look. So, no, we have not gone into this. I suppose we would. That will be the next thing we go on to. Yeah, for now, let's try to clear off what we have.
Okay, thanks. While we're talking about the hospital, someone mentioned under healthcare act, the max minimum landing size is 3.
Yes, I agree. Yeah. That's correct. Yeah, so, the minimum landing size is yeah. Yeah. What the Schedule 11 does is that it imposes relative depth of the landing, the depth of the landing relative to the width of the stair. If the inverse narrower the stair, the deeper the landing. That is what the UBBL specifies. It doesn't in any way it, because none of less than what
The is more, but the depth is some of the depth is less.
yeah, it's just interrupted space. Schedule 11 is for the purpose of ensuring that the people turn and maneuver the structure without having to tilt the structure upright. Keep it on horizontal. It's not a contradiction anyway.
You have to comply both. You have to comply both. Right? Yeah.
Yeah.
Ah.
It is not in contradiction. It is not in contradiction. Schedule 11 for purposes of
Huh? So that one is a that prescriptive then if the healthcare act saying 1.8, then you have to do 1.8 also lor. It's a minimum under UBBL, but healthcare another minimum you comply both. Yeah.
And anyway, for hospital ward, it really said UBBL the minimum weight one. So we put that in.
Then this one is actually quite similar also. Landing that based on 11 schedule or the CCAP's requirement for 1.3. We discussed that one.
Okay. To answer this question, going back to the general thing, the prescriptions are like the absolute prescriptions. Some of the prescriptions are minimum, that means you cannot go less. Some of the prescriptions are maximum, like travel distance maximum, you cannot run further. Staircase dimensions are minimum, you cannot be less, you cannot be narrower than that. Threads and risers, you've got both minimum, maximum, you cannot be less than that thread, and you cannot be more than the thread. So in any of these bylaws and any of these requirements, always remember that you need not do it absolute. That means if that schedule says for a staircase width of this, you need a minimum landing depth of this like that, that does not mean that's the absolute dimension. Correct. In that context, it's minimum. It's not maximum, right? In some contexts, like Bombay applying a test way. Why do we always start off designing applying a test way by drawing parallel lines 6 meters apart? Right? Why? Why do we do that? Because that's absolutely minimum. When you turn around the problem, you need anything. Or in many situations, if you're designing for a fire twin cable, very large, a very big floor plan, you don't start with a fire appliance here. You need four. Fire, not so. Let's be very mindful. Let's be mindful of what the dimensions actually are. Are they minimum prescriptions, maximum, or is it a range? In any case, don't start off. Always look for practical. What is practical? It's like our bedrooms. we all have minimum dimensions for habitable rooms. Go back to I think the three, is it? Space and ventilation, right? We all know that, right? The size of the first room minimum shall be, I think, 10.3 square meters or something. The third room shall not be less than 6.5 square meters. Have we ever started designing a house, master bedroom 10.3, second bedroom, what 8, and third bedroom 6.3? You don't, right? Except for low cost house. Low cost house to go for minimum lot. So if the intention is to go for minimum, then mind that but if the intention is to do something something that
Thank you for this constant reminder. It's very important. The next one to advise on the use of protected escalators and elevators as an option with protected staircase.
Okay. You would have realized that the schedule on exit capacity schedule, we got horizontal exit, story exit. Then escalator is no longer in that second schedule. Cannot. Lift or stairs. Lift or stairs. Yeah. Lift or escalators are no longer. You cannot allocate any exit capacity of escalators anymore. Because escalators do not have the correct check that. Yeah. In the previous time, previously we have allowed escalators to use the app in case the escalator stop. They must stop. You cannot even reverse stop. You cannot move. Right. So we have about that. But now because of the set diagram, it doesn't perform. Yeah, because the
next one is on fire barrier. While 750 mm partition required to separate floor to floor, does 750 mm divider apply to neighboring units? I think the question is like on plan view, yeah. This unit and the adjacent unit. Yeah.
Horizontal, there is another clause. There is another clause opening adjacent partition. I can't remember that there is a clause, a very obscure one. Actually, opening between adjacent, opening parallel. Yeah. It may be done. It may be. I can't recall.
This is regarding PS 8414 design installation in terms of spacing of internal fire barriers must be identical to the spacing of the internal barriers of the tested module.
Okay. The sample size is to test both the horizontal and vertical spread of the fire. So whatever fire stop that is installed in there to contain and to get that cloud will have to be computed in the actual installation. So there's no the testing DSA 414 just the parameters for the test. It doesn't in any way specify your material or what are the components you have to use. It is just a parameter that specifies that the thing form within that parameter. So how you design it highly, how you design it for it. And so yeah, if you have fire stops in place at interval that will achieve that test result, then that same dimensioning have to be applied in your actual production.
In this case, when we apply like that, the maximum if you tested maybe 3 by 4, we can reduce, but we cannot.
Yes, you can. You can the same reasoning once. You can add on, but you cannot.
Okay. The next one is
That one.
any definition of the
I spoke
cladding.
and- Yeah, that's a good question. We have not actually discussed what to do with those green walls, vertical green walls. Do we regard it as cladding, or it's supposed to be green, right? It's not supposed to burn. So we haven't actually talked about that. But the what this standard says is that cladding, all cladding with a cavity. That means any cladding that applies dry with the mounting and it doesn't apply to something that when fixed or say to a granite. If you actually use cement mortar, you fix the granite with the wall, it doesn't apply because there's no cladding. But the moment you have a cavity and you have hooks or mechanisms hold to take place, then all cladding must send. Those are open, not closed cladding. They're not closed cladding. That so I'm not too sure because we have not actually correct. That's why I mentioned the Malaysian standards. I did two criteria. One is structural collapse, the other falling because precisely because of that. Yeah, the aluminum windows, strips, and even for breaker panel. It's a very, I would say, why we are testing cladding means something solid. It's got cavity, it's held together by physical structure of some sort. By the definition, yes. By definition, yes. Yeah. By definition, yes. By definition, I'll say yes. So yeah, we're looking at even those maneuvers and all that. It may, yeah. I've not, we have not actually discussed it down to the level. Okay, let me raise it up. But for now, because for now, the obvious ones are definitely closed cladding, solid cladding. There'll always be, is it one line something, we have to be so careful. We have to define it down to that degree. For example, I was mentioning incorporated. So this cladding, all the one up. So incorporated, I would say, okay, so the incorporated really that's not clean because what you have is like right and no longer correct. So if you go by the standard operation, then if you don't find that, then someone will say every error comes from the so we have to define that percentage of operation now. Correct. And by percentage of the definition of corporation, we did it for open structure. With open structure, we said that the open structure, then we also define how to actually any opening less than 1 square inch. And cannot. So if you have a corporation, you have measured every side of every corporation. But if each corporation left that movement, I will not regard that. Oh, sorry, my apologies. Oh dear, where did I miss out? Okay, it's about the corporation. So So in the open structure, we did have the definition. So maybe we have to apply the same thing to this cladding if we want to go that route. But for now, it is saying in general, all cladding, 10%. So we just kept them at that level. And enclosing panel, yeah, correct, yeah. Then people are saying that, oh, we all know, we say a granite cladding. Really, granite cladding, we all know it's non-combustible. Yeah, great, fantastic. But what is holding up the cladding? Right? A lot of times they use aluminum. So aluminum, when you reach 250 degrees, it melts. The entire cladding granite slabs will be raining on the poor guys down below. So, yeah. Okay, I think it's just been introduced. Let's keep it that way. I'm sure it will develop.
I think we should stop at the questions before 1 p.m. There are some other questions. The next one on the 6-meter bomb access road, must it be 2 meters away from the outer side of the external wall, even the building is not of
that one is called the near edge. So the near edge is defined that the near edge need not be a physical edge. The near edge doesn't have to be a physical element. It doesn't have to be a physical curve or apron. It is just measurement. That means the legal risk of the fire appliance access and road allocation must be measured, known,